I get the microphone.
Hello. Hello, guys. Guys, if you have Minecraft open, I'm not going to repeat myself. Okay, if you have Minecraft open, close it. If you're playing ML, close it, uninstall it. If you're playing PFP, uninstall it also. If you're playing League, uninstall it. If you're playing Roblox, close it. What else? If you're installing something right now, you should have done it last night, but we will help you later.
Yeah, honestly, it's fine.
And yeah, so this is the last day of training. You're allowed to clap. Yeah, for all the people that have managed to come for all 5 days of training, thank you very much for showing up and supporting and learning. Hopefully you have had a good time or a fun time or an educational time. Today is going to be the last set of training that we're going to be doing. So before lunch, my good friend here. Hi, so our trainer Xenon here will be covering forensics, which is a category that exists. And after lunch, we will be doing some challenge walkthroughs. So we've given you all quite a bit of homework over the last 4 days. We will be walking through some of the homework challenges so that you guys can learn a bit more. And I think one of our sponsors is gonna talk to you all for a bit, and then afterwards we'll close off, we'll answer some questions, and you all can rest up and play the qualifier tomorrow. So I'm gonna hand over the time to Xenon. Everyone please give them your full attention. Right, so thank you.
Oh, onboarding for the platform. That one is, yeah, it will be after forensics. Don't worry about it.
We'll answer a bunch of the questions to do with the computer and the platform later. Right.
By the way, for the forensic hunters, should I just walk through it later after lunch?
No, like we see how fast it takes.
Yeah, sure.
Hello everyone, so yes, today I'll be presenting forensics, a very interesting category that is not controversial at all in CTFC. So yes, you're asking, well, what is forensics? Well, I mean, I think you have a kind of idea of what forensics is, you know, it's kind of investigative because it's the kind of thing that you use in a criminal investigation. And as such, it also requires quite a lot of tools for actual forensics, of course. And similarly, forensics in CTF, well, does specifically digital forensics out of all the categories, but still requires quite a bit of tools. And yes, the problem is, unlike other categories where it's more akin to solving a problem, forensics is more about looking for things. Like you might be given a massive dump file and you have to find the flag based on clues. And a lot of the times this can mean that the challenges end up being quite guessing because you kind of have to spend a lot of time searching and you just manage to guess the correct location. That's very good. And then since forensics requires so many tools, very often the challenges can also require specific things. There are examples of challenges where, for example, the author may require you to use their specific tool, which is not very good, but yes. And all of these in combination results in forensics having a pretty poor reputation in the CTF community as a bad category. But then, why then do I think that it requires so much emphasis to be given its own slides and everything? Well, I think that forensics challenges, although a lot of them can be of mediocre quality, a good forensics challenge is still extremely rewarding to solve, and in a way a bad forensics challenge is also quite rewarding because like you've outsmarted them. And besides other categories, I feel like forensics is very applicable in real-world scenarios because a lot of the times, even outside the cybersecurity context, you might be going through or trying to load corrupted data or like a dead hard drive, and the knowledge you know here will hopefully be applicable to the future. So yeah, I'm hoping that all of you guys can pick up just a little bit of forensics and use it in your day-to-day lives or tomorrow, perhaps. Yes. So some basic prerequisites. It's a lot more approachable than those other categories in a way because a lot of the tools are kind of already made available online. Still, you should be good friends with any search engine of your choice because you need to do a lot of research because it's a kind of a wide category. Some familiarity with the command line will be useful, especially for specific tools like bin walker volatility, although you can get away a lot with just using online tools. and also a lot of patience, because some of the challenges will not be very fun. So yes, the outline for today will be, first I'll cover files, the structure of files, and how to identify and obfuscate them. Then some short steganography. And finally, about how to obtain data from several data sources, as you can see here. So first, what are files? Well, they're the basic unit of data for an operating system. And they comprise of bytes, which need to be decoded in a specific format to be readable. Wow, the colors do not look as vibrant as I hoped they would be. But it doesn't matter. Files often come with metadata, most notably the file name, among other things, yes. But of course, how do you know what type of file it is? That's quite important after all. If you don't know something's an image, you can't really decode it as an image, and they'll just look like garbage bytes. Well, there are a few methods to do so, and different OSs take different methods. For example, for Windows, it simply just analyzes the file extension. So if you try it as a .text, it'll open it as a text. If you write it as a PNG, it'll open it as a PNG. However, of course, this isn't that good, because if you have no file extension, then you have no clue what the type the file is. So most other OSs, especially Linux-based ones, take a different approach. Specifically, they analyze the file header to look out for, well, the structure of the file header, but more specifically, the bytes at the start, known as magic bytes, because these usually are a human-readable and specific string of bytes that will identify the file type. And by doing so, we can figure out what file it is without needing a file extension. For example, if you were to check the command line, if you use the file tool, it will check the magic bytes for you and tell you the type of file. Of course, this leads to a very simple kind of forensic challenge, where they just delete the header and then expect you to figure out what the file is. Of course, this is very fun, especially when it's something like an image, then you have to guess the dimensions. But yes. Now, it might be useful to, of course, knowing that a lot of OSs identify files from the file header, it shows a very easy way to hide files within other files. Specifically, we just kind of stick them inside or at the end of the file contents and hope that the decoder doesn't notice, which for the most part, it usually works. And yeah, for some file types, it will ignore the data in the middle, but for almost all of them, they will ignore the data at the end. For example, for XML-based file types like PDF, if you just stick it in the middle with a correct tag, it will just ignore it. And using some kind of utility like binwalk that can carve out the files automatically by looking for the header, you can reobtain the hidden files in a simple manner. Yes. But of course, this is kind of terrible as a way of hiding files, because if you just open it in like text edit or something, you can see the other file. It's just still in there. It would be not much nicer if we could hide a file in a manner that is completely non-obvious. If you didn't know that it was there, you would have no way of finding it. And that's what steganography is about. The kind of main idea is that you take a file's data and you kind of spread it throughout another file in thin enough that it is not noticeable. So nice information-dense files like music, audio, and images are best for steganography. So the most common form of image steganography is hiding it within the least significant bits of each pixel in the bits of data. So you can see here, I assume you guys learned what the least significant bit is in Rev, right? Okay, yeah, sure. So, yes. You can see here we have this kind of extracted the pixel data, split it into red, green, and blue, and the alpha values for each pixel here. Although, I mean, it's kind of an estimation, but it's a diagram, it's fine. So let's say we want to hide the text low high in it, right? So what we would do is that we look at the least significant bits here on the right for each of the pixel values, R, G, B, and alpha. Right now, they don't really say anything useful. As you can see, these are not really valid bytes, but it's fine, because we're going to replace them. So once we overwrite them with the bytes of B and J, we now have our data hidden in here. But since they're the least significant bits, we basically only change the color by the lowest bit. The actual color doesn't change by a lot. And you can see it really looks the same. But in doing so, we have managed to hide data within this image. And one thing to watch out for is that sometimes specific programs, because there's no standardized way to do this, will order RGB and alpha differently. Sometimes they omit alpha. So when you are using a tool like CyberChef or some other online tool, they will usually allow you to set which order and which colors you are looking at. Also, there are other tools for image steganography that you might have heard of, e.g. steg-hide or OpenStego. These work by more convoluted methods, which can be sometimes more resistant to change, because of course, if you were to compress this and all the pixel colors change, then you would lose the data. But generally, for these ones, you can use something like a Perisolve to automate most of the checks. Yes. As for audio stag, I won't be covering it here to save a bit of time, but it is very similar in that there is LSB and there's also a spectrogram, but yeah. Now, on to data sources. In actual digital forensics, as in BlahajCTF, you're very often not going to get file data as is. You're not going to give them like a USB stick that just has files in it. Usually, you'll have to recover them from a raw disk image, a memory dump, or some network traffic logs. As such, a lot of CTF challenges often make use of these as well. So firstly, we're covering disk images, which represent entire disks. And most often, they will contain the operating system because that gives you a lot more information. But sometimes some of them are minified, so you only have the important files in them. And you can either mount the disk image directly if you have it, or you can explore it in dedicated programs like FTK Imager, which unfortunately is Windows only, or Autopsy, which is not Windows only, but not very easy to install. Yes, and while I won't be explaining too much about the layout and the workings of common OSs, having a good feel for it, it will be very useful and save you a lot of time. Like knowing where app data is or the home directory, especially if the challenge description gives a hint about what you might have to look for. Yeah. But of course, this does make it kind of guessy, so it's useful to have automated tools to search common things for you. Autopsy has that, I'll show it in a second. Yes, another nice thing about disk images is because they're the raw disk, stuff like deleted files, since the deleted files are still on disk and just marked as deleted, the data will still be present on the disk and thus be recoverable. Okay, I'm gonna switch to Autopsy right now. Okay, wait. This is extend, right? There we go. Okay. Sorry. Can you work with me, please? Yep.
I have an FTK image used like previous CTF. So which one should I use? Autopsy or FTK?
In my opinion, FTK is faster and more lightweight. So if you know what you're looking for and you want to open it quickly, then it's pretty good. Autopsy, on the other hand, is, in my opinion, a bit more bloated. But as you can see here, there are these nice automated tools that find common things for you, although a lot of the time they won't work. So you kind of need to prepare yourself for looking at manually. So I think if you have FTK Imager, you can use that, but I'd rather you participants install Autopsy because I think it's easier to use. Yeah. Give me a sec, guys. Okay. All right. Yes. Okay, so here's a random image I have from a previous CTF challenge. So I can just show you how Autopsy works. So you can see here, up here in the data sources, you can kind of just navigate through the files. Although it has been pruned a little bit, you can still kind of see the user file, and you can look at what they do, like the desktop. This brilliant thing here, which is not that useful to CTF challenge, but yes. And the nice thing about Autopsy is that while it will load in your data very slow, because it's doing a lot of analysis, once it finishes the analysis, you have all these fun things to look at. Wow! You can see here we have recent documents, which quite nicely appear to be linked referencing the flag. Unfortunately, the flag is not here with us anymore, but I mean, it's part of the challenge. And the other nice thing is that for common browsers like Internet Explorer, Autopsy will automatically extract stuff like web history and the web cookies. So you can see that this wonderful person has searched up top productivity apps for Windows, among other things. So yeah, if for example the CTF challenge description says, oh, I searched up some kind of funny thing, then this would be quite useful. For example, there was a previous challenge where the guy searched up some I don't know what it's called, sorry, some random file, and then you have to download it from there. And you also see, it also nicely caches the cookies, although this isn't that useful. So yeah, you navigate here on the left, and then on the bottom pane here, you can see the actual data, so you can see the cookie. But yeah, it's not super interesting because this isn't the main part of the challenge. But I'm hoping that this can just show you all the cool features that Autopsy has to make your life a little bit easier. But in the end, you probably will have to spend a lot of time just digging through the folders, so yeah, fair warning. Okay, back to the slide. Oh wow, I think I might have been speeding. Do you guys think I've been going through the presentation a bit fast, by the way? Have you guys been able to keep up? How to use Auto? Okay, that's fine. I think it would be good to have challenge walkthroughs later, so since at the rate we're going to end quite early, we'll have time to go through it. So don't worry about it. All right. Okay, so other than disk images, we also have memory dumps, which, as opposed to disk images, they represent RAM as opposed to, well, the disk. And the nice thing about representing RAM is that you get a lot more information. Other than files in use, you also get all the running programs, the list of the PIDs, what spawned which, etc. And you can analyze these with volatility, although volatility will need to know what OS you're using, or else it can't really parse the memory layout. However, we're not going to go through this today, which I realize is for lack of time, but I now think that we have access to time, so maybe I will go through it later. We'll see. Yes, and finally, we have our favorite sharks, specifically packet captures, which represent capture network traffic. These usually are in PCAP files. I don't think you need to be a genius to figure out what PCAP stands for. But yes, you open these PCAP files with Wireshark to analyze them. And, well, I did say that I don't think we have time to have a full networking course, or maybe we do. But yes, you want to look out for suspicious activity, or again, things that the description has told you about. Specific protocols like HTTP or RDP, remote desktop protocol. Because there's a lot of friends challenges that tell you, oh, I'm streaming my desktop, and then they give you the packet capture, and you have to reassemble the desktop image from the RDP packets. Yeah, and also packets sent from and to suspicious IPs, because, yeah, this might be an attacker. Ooh, scary. Anyway, yeah, I'll switch back to duplicate so I can show you Wireshark real quick. Okay. So I've already opened a few example packet captures just to get your feet off the ground. So you can see, usually packet captures are very dense because, they capture all network traffic, which includes a lot of not very useful things. Especially in this case, there was this guy spamming it, so it's not very useful. So yes. Since there's a lot of noise, you might want to look for specific things that might be interesting. So you can see there's some green here. Green means HTTP, so there might be some HTTP traffic that we can look at. So to do that, we go up here where it says apply display filter. And we apply this display filter that sorts it by protocol. And now we can see that this wonderful person accessed /ms download this random thing. And yeah, from these, you can see that each request has this corresponding response from the server, marked as so. And from the response, you can see, you can actually get the data. Not this one, let me find one that actually has data for you to look at. This one, brilliant. Yeah, it has this brilliant image. And you can extract that image by going here, right click, show packet bytes or export packet bytes. You can also look at here, but you can see it doesn't decode the image for you. So if we're gonna go out, I guess I can point out some other suspicious things that might be useful. For example, very early on, you can see that there's all these gray TCP requests. Those are TCP requests that get dropped. And if you look here, you can see that you can see that the destination ports are randomized. This is because that whoever was trying to attack this thing was doing a port scan and just sending TCP packets to basically every single port hoping for a response. So yeah, that's what the gray means. The gray means no response because I would be surprised if most of your ports were open to traffic. But after a while, the guy finds the HTTP port. Another interesting thing that occurs in this massive problem is there's some FTP stuff around. So if I saw my FTP, you can see there's this guy this is after the system has been compromised, by the way. There's this guy who's running requests of FTP, which is kind of hilarious. But yes, if I remember correctly, the layout of this challenge was you first get the kind of the like malware that the attacker got the victim to install through HTTP, and then after that you kind of look at all the FTPs to figure out what he's doing and where secret.txt went. Oh no! Okay, let me try zooming in. Cannot. Okay lah. But yes. What? Okay. Yeah. So yes, BlahajCTF tried to make your life quite a lot easier, but there are some things you still have to do manually, such as if there's encrypted traffic, you will have to provide your own key. Usually, if it's part of the challenge, they will usually have it somewhere lying around. So it shouldn't be too bad. But yes, that's why being familiar with Google is important, because a lot of things that I don't think I can cover in. I say that, but it's 9:40, so maybe I can. Who knows? Yes. There are a lot of other types of things, by the way. For example, BlahajCTF can also capture USB traffic, which is used for very, I wouldn't say straightforward challenges, but simple challenges where they just, let me zoom in a lot, where they have like a USB keyboard or a USB mouse, and you need to get the original, you need to extract the data out of that to figure out, oh, they type.
You're trying to do like, you're trying to like check the keystrokes.
Yeah, like so. And there are pretty good tutorials online on how to do these for challenges. So yeah, these are not useful. Yeah, I do realize that I think I really don't have that much content for forensics because it's a lot of it, it's a much simpler category than, for example, binary exploitation. A lot of it really comes down to, what do you call it, gut feeling in a way. Like you just kind of, once you do enough forensic challenges, you kind of know what they'll throw at you because there's really only so many things. But once in a while, they'll have like this random challenge using some random tooling, and then you have to go Google how it works. And in my opinion, those are the more fun ones. But yes. Guys, should I end my presentation now? I don't really have a lot more content to talk about. I mean, do you guys want time to work through the forensic challenges we have? Yeah, sure. Okay then, so yeah, I guess that's really all for the presentation. It's a much shorter presentation than every other day, but you know what, maybe it's a good thing. We end off on a higher note. So yes, I hope you guys at least took away something, and if not, hopefully you take it away from the challenges that we'll be going through later. Yep, thank you. Yeah. Okay, wait, how do you say that again? Give me a sec, guys. We just have like a zip. Does it already happen?
Hey, you're
Okay, so in another
you're
10 minutes, we
leaking
will
the.
give you forensics challenges for like 5 of them. These are the
No,
and they will train you in
you leak
forensics.
the organ pieces.
It's okay. I know, but the org chat doesn't have anything in it, so.
Meow.
I know, I'm sorry. Look,
Can go mute. kann es auch Autopsie. Okay, wait, guys. Chat. Everyone in the room, look up. Stop what you're doing and look up. Okay, so I know we said we were going to go through the challenges, but I've noticed that some of you all don't know how to navigate Wireshark, or didn't really get the gist of it just now. So I'm going to walk through Wireshark one more time, but slowly, so that you guys can understand what Wireshark is doing and why it's relevant. Okay, so first and foremost, right, let me get a microphone. Actually, I don't need a microphone. So, when you open Wireshark for the first time, right? When you open Wireshark for the first time, it should look like this. Does everyone see this when they open Wireshark? It's just like blank, and then it shows like capture and all that. So, the primary functionality of Wireshark, besides packet analysis, is packet capture. So this means whatever networking your computer is doing, Wireshark is able to capture what that networking is, and then later you can analyze it. So when we send you a PCAP file, right, or a PCAP.ng file, what that is an existing network capture. So that means like you take someone's computer that has been like connected to the internet or connecting to other computers, and then you note down all the connections that it's doing, and then we can load it into Wireshark later again, and then analyze it. So when we want to start analyzing something, let me magnify. When you want to start, why did I put it all the way down there? Okay, well, if you want to open a PCAP for the first time, right, it's really straightforward. Just like in Gitra, right, you go to File, and then you open, and then you pick the file that you want to look at. So once you open a PCAP, right, you'll get blasted by all of this information. So let us go through bit by bit what all of this information is, right? Okay. Can everyone look at the screen? Can I get all the eyes on the screen? So when you open a PCAP for the first time, right, you're gonna get a display like this. So what this is every single packet. So like every bit of information that has to do with the connection that we're analyzing. So when you first open it will be in order. Okay, so what you have to remember is computers need to have a way to communicate with one another, right? Because like a computer can just send 1 and 0s to other computers, but the other computer needs to be able to understand what the 1s and 0s are. So when we perform networking between computers, and as you can see IP addresses here, right? Each IP address corresponds to a computer in the network. So like for example here, 192.168.12.136, that's the IP address of like computer A, and it's communicating with computer B on 35.213.130.27. So IP address, source IP address, destination IP address. Make sense? All good so far? Okay. So when computers communicate, they need to use a thing called a protocol. So a protocol is a way of describing information to one another. So imagine the following, right? Okay. Imagine the following. Like when you are watching a YouTube video. YouTube videos are video streams, right? A video stream is composed of a lot of images and a lot of audio. The way that I will encode this information would probably be different from how I encode, let's say, a news website. When I go to a news website, I'm just getting text and images, right? So there are different formats and different ways to communicate those formats between computers. So some common protocols, and you can see the protocol that's being used. Wireshark will tell you what the protocol is in the protocol column. So you have protocols like UDP, HTTP. Does anyone know what HTTP stands for? Hypertext Transfer Protocol, right? You have TCP, that's what, Transmission Control Protocol.
I think it might be important to note that, like, how these work is that the protocols build up the lower protocols. And you can see you have all of them. You have IP and Ethernet, but Wireshark will try to decode it as the highest possible protocol, as the highest level, because it's probably going to be the most reasonable. So the TCP segments will be, like each of the TCP, you can see the individual ones, but usually Wireshark will try and combine them into the original HTTP request, so that's more readable.
So this is similar to when we were talking about layers of abstraction for web, right? Remember that at the very base level, everything is ones and zeros, right? And that is what is being represented here, down here, right? On the wire. So remember, bytes are bits. These are the actual bits that are being transmitted, like either through Wi-Fi or on the wire, on Ethernet. And then once you break down the way that these bytes are grouped up, you have your protocol, right? So the protocol is just a way to structure the data and make sure that the computer on the other end can interpret the data in a meaningful way. So something more practical, right? In a packet capture, because your computers are communicating with a lot of things all the time, right? If I were to idle my computer and just let it capture packets, I would get packets being sent to Spotify, Discord, YouTube. Sometimes I capture some packets going to like my AirPods or whatever, right? So there's a lot of stuff that gets captured. So there has to be a way to filter. So for example, in this gigantic packet that we have, I don't know if you guys have this. I don't think you guys have this. I can filter by protocol. So for example, let's say I only want to see HTTP, right? So let me cancel that first. If you go up here in Wireshark, you notice there's a thing that says add apply a display filter, right? So this is a way of filtering through all of the packets and all of the nonsense that's inside the capture. So I can specify a protocol that I want to filter by, let's say HTTP, and then it will only show me packets that use HTTP. And you can see it's in a very readable format as well. So all of the individual HTTP requests that are being made over the wire have been captured by Wireshark. So even though the actual bytes and bits look very messy, like this, Wireshark is able to decode it for us. So if you look over here, so like on the bottom left, the bottom left is what Wireshark interprets the packet to be. So it knows it's HTTP, and then it breaks down the bytes based on what information they encode individually. So we can see a HTTP request, and we can see each individual part of the HTTP request, like the content length, the connection, the content type, and most importantly, well, maybe not most importantly, but pretty important, it actually has the HTTP request result here. So like this is what the server is sending back to the end user. So something else that is useful, you can follow a stream. So HTTP packets, right? If you just have them all like this, you can tell a story, right, of all the connections that this computer is making. But sometimes you want to be a bit more specific, and you want to look at one specific conversation between a computer and a server, right? So if you right-click, you can follow. So let me magnify for those in the back. If you right-click on a packet, there should be an option to follow, and then you can follow the HTTP stream or the TCP stream. And what that will do is it will isolate all the relevant packets to do with one conversation, and you can display it in whatever format you want. So this is as raw bytes, right? You can encode it as ASCII, and then it becomes readable. So you can see what this stream is. There's a whole HTTP conversation with the server, right? A GET request followed by a response, then another GET request, then another response. This is one conversation. There could be multiple conversations that occur on different streams. So like this stream, there's no real information to look at. Actually, most of these are mostly blank. But this is something that you will encounter when doing your challenges. So, which one did you upload? I can walk through it then.
You walk through it right now.
Right now.
It's child yeah.
Child to where was it? Here, right?
Yeah.
Child to document.
Yeah.
Okay, so
I want to say one last thing.
Yeah. So while filters are quite nice, I feel like if you don't really know what you're looking for, it might be more useful to sort it by like source, destination, or protocol, because then you can look for specific things that might be interesting, that are notable, that you might want to look into. Yes.
yeah, so like Xenon said, right? I can, because this is just a big table, so usually it is sorted by the packet order, which is the first column, but I can sort it by time. This is kind of cool because actually packets do not necessarily need to come in order. Packets can come out of order in different times, but the protocols are able to reorder them. I can sort by source, so maybe I only want to look at packets coming from one specific source IP address. I can sort by destination, same thing, except for destination. I can sort by protocol, so I can cluster together all of the packets belonging to the same protocol. I can sort by length, so maybe I want to look at suspiciously large packets, because maybe they contain more information, so I can sort by length. So you can see there's this really gigantic one, right? And I can take a look at what is being sent there. So with all of this in mind, I'm going to walk through challenge number 2 with you guys, like step by step, like right now. So here's the thing about forensics, right? Most of the time, a forensics challenge will tell you what the goal is. So like, let's say we give you a disk image. Maybe we will say, oh, I am looking for the browsing history of this person. Or maybe I'm looking for the cookies of this person in your browser. And then when you find that information, you'll find the flag. If we give you a network capture, sometimes we'll say, oh, this person was logging into a website on an insecure shell. Can you find their password? Then maybe the password would be the flag. Or maybe this person was stealing information and we captured the networking for that. Can you see what information they stole? And maybe the flag will be there. So the goal of the forensics challenge will usually be quite clear. We will either say there's information hidden inside the file, or there's information for you to look for. So let's look at challenge number 2 together. So everyone go to Wireshark, file open, and then we open child 2. So I personally have not looked at this challenge either. So I'm going to step through the thought process with you all in real time. Okay, so when you open child 2, this is what you guys should see, right? We'll be seeing a bunch of conversations, and the source and destination IP address is 127.0.0.1. Does anyone know what this IP address is?
Google.
Any guesses? Any guesses? Google is wrong. Any other guesses? Edge. Okay, the truth is, this IP address, whenever you see it, 127.0.0.1, correct, it is referring to the computer itself. Or sometimes you call it a local host. So if you are hosting a server on your own computer, and you connect to your own computer, you will get a connection from 127.0.1 to 127.0.1. So how do we tell the difference between them, right? Any guesses how we can tell? Because the IP address is the same, but obviously if I'm talking to myself, I still need to, I've got a mouth and I've got an ear, right? Or well, I've got 2 ears at least, at minimum. The computer also has a mouth, which is the source, and it also has its own ears, which is the destination. But if we both define them to be 127.0.0.1, how do we tell the difference? Any guesses? The ports. The ports. So an IP address usually doesn't just exist in isolation. An IP address usually has a port, a source port or a destination port. You can think of it. Why does this thing keep disconnecting? So you can think of this literally like a port, like a port where ships come in and come out of, right? Because one computer can have multiple ports to send data out of, and can have multiple ports to send to receive data from. So even though the computer has one IP address, it can have multiple ports. Some common ports that you see, websites usually run on port 8000 or 8080 or 80 for HTTP. And for HTTPS, which is secure HTTP, it's usually 443. Another common protocol that you will find is SSH. Why does this keep disconnecting? Okay. Another common protocol that you'll find is SSH, which usually operates on port number 22. I don't know any other common ports.
FTP is 21, I think. If y'all end up doing Windows shit, if y'all end up doing Windows, there's 135 and 139. That's what SMB. LDAP is 3219. I think none of y'all are understanding this, so it's okay.
So you don't need to remember or memorize port numbers. As you can see in my 20 long years on this earth, I still do not know which port number HTTPS is on off the top of my dome. Because usually you can just look. You can just look in Wireshark, it will tell you what the ports are. So, back to analyzing this packet, right? We can see there are a few conversations using TCP, and Wireshark has managed to identify that there's a conversation going on in HTTP, right? So I can click on packet number 6, which is in HTTP, and this is a GET request. So if we go over here on the left-hand side, where it breaks it down for us, we can see it makes a GET request to the endpoint / and it is requesting for the website localhost 8000. So putting together what we just learned, since this is a conversation with itself, right? 127.0.0.1 is localhost, and it's communicating on port 8000. So it makes a GET request. And we can see all of the other information in the GET request, right? So every request has what do you do to a request if you receive a request? You send it back.
Send what back?
You do what? Open-ended question. Okay, to a request that is made to a server, the server should send a response, right? And the response is the answer to the request. So if you scroll through all the way down, you'll notice the response is in packet number 51. Now, there is a chance that it is really annoying to go through all the packets because you could have a lot more stuff in between, right? See, in between the first packet where we made the response, request, packet number 6, we had all of these other TCP requests and responses coming in between. Now, this is a small number, but if you remember what I mentioned just now, you can right-click from here, follow HTTP stream. So it will isolate all of the relevant packets in this conversation, in this HTTP conversation. So once you click that, what do you mean, which one? Right click, follow HTTP string.
Do this, follow.
Follow HTTP string. And then it will process, and then you can see the contents of the HTTP conversation, right? So you can see the GET request at the start. So this was packet number 6, the initial GET request, in red. And then in blue is packet number 51, which is the response from the server. And you can see the server response is a website. You can see HTML here. It's a website, and the website has an image inside. However, you can't view the image because this is the raw data that makes up the image in base 64. So let me show you a trick to handle this.
I'm going to do Cybertruck.
Okay.
Okay, so
Cybertruck is good.
you can.
Oh, wow, cool. It's quite big, like, it's a dumb. I think you can just say that.
Okay, so you notice there's a lot of data inside this response, right? So let's close out of the conversation. Let's go to packet 51 together. So packet 51, as stated, this is the response, right? Something that you can do is, okay, where is that? Copy, files folder.
Okay, I can export like a file.
Yeah, I think it is, but that's a bit cringe.
Yeah.
So,
I'll just copy the field.
so anything that Wireshark manages to decode, right? Let me open Notepad real quick. Let's hope there's nothing incriminating in Notepad. I don't know what that was. Okay. So if we right click on any of the decoded information in Wireshark, you can right click on it and you can copy. So there's multiple ways, there are multiple formats that you can copy the thing in. So where's my magnifier? Or I can't see that. So if you go to copy, you can see there are multiple formats you can copy it in. You can copy it as a hex dump, you can copy it as ASCII text, you can copy it as a hex string. So let's see what happens if we choose hex dump. If we choose hex dump and then we paste it into something, you notice it just gives us the bytes of that field. It doesn't decode it for us, right? However, if I were to right click it and I were to copy as ASCII text instead, when I paste it, it will be in readable ASCII, because if you remember from Wednesday, characters are numbers, numbers are bytes. So these are the bytes, which are the numbers, which are the characters, which is the string, which is the string, which is the sentence. So let's go back to our HTML, right? So very nicely, Wireshark has managed to decode and tell me how many lines of HTML the server has responded with, right? And we can see you've got your HTML headers, you've got your style tags and the retext, and then you've got the image here. You've got your image in base 64. Aha, base 64. You ever think about that? So I can copy this. Let me get this out of the way. I can copy this as ASCII text, and I could paste it into Notepad, and then I get bombed with all of the text that makes up this image. Okay, so we are one step closer to actually solving this challenge. The problem now is we have all this base 64 stuff, but how are we supposed to view it as an image, right? So I'm going to do this the naive way, which is the very simple and straightforward way, which is, this is a really big font. If we go to the first character, which I would like to go to the start of the file. Okay, so in HTML, right, the actual data of the image is starting at this point. because you notice everything before it is just preamble, right? It's just telling you it's an image, it's in base64 and all that. So only after the comma and then IV, BUR, blah, 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 blah. This is the actual base64 image. So what we can do is we can remove the front view parts. So removing the front view parts, you start to isolate the actual data, right? And then if we go to the end of the file, we're going to go to the end files.
The first one is I lost it. Right?
Huh?
What?
First one is I lost it.
Wait.
Don't get ahead of yourself.
Yeah.
So at the very end of the HTML, we have the rest of the tag. This is also not like the actual image data, so we can delete this too. And now we have isolated the raw base64 data that encodes the image that we want to see. So I'm going to copy all of this, right? I'm going to copy all of this, and then I'm going to go to my favorite tool. Wow, that's a lot of tabs. I'm going to go to my favorite tool, CyberChef. Take your time to copy. I mean, even if you're still copying, I'm still going to carry on. So I can paste all the base64 stuff into CyberChef, and then it's just going to be there for now. And then I can indicate that it's from base64. And then it will start to, it will decode it. And then notice that after decoding from base64, right, the start of the file starts with Anyways, if you guys have been following along and you've pasted the thing in CyberChef and you've decoded from base64, you'll notice it starts with PNG. And what's PNG? PNG is an image file, right? So CyberChef actually can render the image file for you. And then, ta-da, the flag is there. The flag is in the image. Yeah.
Take your time. Right, so.
Okay, so to repeat one more time, right? I will take my base64 and I'll paste it into CyberChef here, right? And since it's in base64, it won't render as anything yet. I need to decode the base64 first. So I use the from base64 function to convert it into bytes. Now the bytes are the bytes that make up the PNG image. And then in CyberChef, there is a render image function. So if you have a byte input and then you pass it into render image, it will display it.
The first one is I lost it.
Yeah,
Okay,
it's
later,
correct,
later,
it's correct,
later.
you are correct. Do
Later.
it.
No.
Good job.
Okay, so this is method number 1. This is
Huh? Yeah,
okay, so this is one method of solving the challenge. Now there are multiple ways to solve the same challenge because we are thinking people and we have disparate different thoughts, right? So let me show you another way to solve this challenge. Can I get everyone's attention again? So if I have a packet that has HTTP data or any other protocol that Wireshark is able to work with easily, right? So like let's say I've done my recon. I've opened my file in Wireshark, I've noticed there's a bunch of HTTP requests and everything, and I know that it's requesting for websites and images and all that. Something I can do is I can go to File, I can export objects, and then, so like, let's say you have FTP communication, right? FTP is File Transfer Protocol. If you manage to capture FTP data, you can dump that FTP data. But we're not looking at FTP right now, we're looking at HTTP, right? So I can go to export objects and then HTTP. And this over here, remember packet 51 was the response from the server. This is the HTML response of the server. And I can actually save this straight away. And save it. I can save it as a response.html. Because I know it's HTML. Let me see where I'm saving this to. Save this in downloads. So if I save it somewhere, right? Where's my? Where did it go? H2. Like, and not save it. Save. Save to.
Xenon, can I save to your documents folder? Is there anything incriminating in there?
No, there's nothing important in there.
Okay.
In fact, I downloaded it quite incriminating.
Yeah, I noticed. I realized.
Okay, so I will save to the documents folder instead. And then I can open the HTML file as is, and it will display the thing as if you visited the website yourself. So notice this took less steps than copying the stuff from Wireshark and pasting it into Cyberchef and doing all the decoding yourself. Able to follow? Able to follow? No? Okay. From the top one more time. Quiet down. Guys. Hush. Shh. I want to walk through it again. So if we have a packet capture that has HTTP communication, right? Wireshark is able to pull out any files that are in the HTTP conversation. So the way to do it is to go up here to File, Export Objects. Then you will choose the protocol that you want to export from. So in this case, we're exporting HTTP objects. In this packet capture, we only have one HTTP response, and it's the HTML of the website that we are requesting. So I will click on this, and then I can save it. Now, when I save it, right, it's not going to figure out the file extension for me. So I need to, all files, right, I will give it my own file name. So in this case, response, and then we give it the extension .html, so the computer knows that it's HTML. Then we can save it. And then once you save it, you can just go to wherever you've saved it, and you can open the HTML in your browser of choice, and it will just render. So everyone able to follow so far? If you've been able to solve this challenge, can I get a thumbs up? Can I get a thumbs up from chat? All good? I'm seeing about 50% coverage. What's going on the second row? Why is my second row not giving me a thumbs up? Seeing like half of you all.
And you need someone to like sitting there watching.
Okay, my apologies to the stream viewers. I forgot to unmute myself. Anyways, where was I? Asking for everyone's attention again. Yes. So let us look at challenge number 1. So challenge number 1 seems to be a matter of identifying what files these are, judging by the name of the folder. So let us go to that folder.
Hi. Just to stress, they haven't seen any of these jobs before, so they are solving it live. So you get to see the thought process. This is valuable information. The thought process of one of the best CTF players in Singapore. Wow, top one of all time. That's true. Wow. That's true.
Oi. Oi. Hey.
Huh?
Hey. Xenon, your WSL doesn't work. Why can't I CD? Why are your permissions good?
This is my old vulnerability that I solved it my
Your permissions are cooked, dog.
Okay, where was I? Oh yeah, so the folder. Guys. Quiet down. I can't hear myself. That's a bad sign. Okay, so one of the utilities that we can use to identify files is file, if you remember. So we can do file mystery file 1. Oh, it's PNG, right? Mystery file 2. Oh, so it's a PDF. Mystery file 3. It's an ISO MP4. So something that we can do, right? Oh, too small. Sorry for my friends at the back. I forgot. Anyways, yes, a utility that we can use to identify files is file. So I think I showed this on Wednesday as well when I was talking about Beacon for Web. So some details, right? XXD is a command that exists that lets you perform a hex dump. So it will show the bytes that makes up the file and dump the entire thing into console. So for example, if I XXD mystery file 1, it's kind of big, right? So if you remember this command from day 1, I can pipe it into head. And then it will only show me the first few bytes. So if I didn't have the file utility, I can look at the bytes that makes up the file itself. And I can look at the first few bytes. You can see here it says PNG. So back on Windows, right, on the inferior system, I can just do .png, add that file extension, and then, okay, great. I now have the first part of my flag, which is an image. Okay, similarly, if we look at the first few bytes of mystery file 2, we can see PDF, right? So I can do .pdf, and then I can view the PDF, and then I can get the next part of the flag, right? Quiet down. Hush a bit. Okay, and similarly, just now we did file and we saw that this is an MP4. So I can go here and I can do .mp4. And then I can see it's a video, and I can see the last part of the flag. So something that's kind of nice, right? We have a way to do a hex dump in the command line, right? Using XXD. Whoops. Where am I? Yes. Oh yeah, because I renamed it. So we have a way to view the hex dump of the file in the terminal. But if you remember CyberChef from earlier, right? I can actually input files into CyberChef. So I can upload a file. I can still upload files into CyberChef, and I can actually perform the hex dump in CyberChef as well. So I can do hex dump. Yeah, the image is there already, but like this is to show you guys that you can do a hex dump anyways. So you can see that we can do a hex dump. Oh, whoops. Or I can do 2 hex. So it will take my raw bytes and I'll convert it to hex, and then I can see it as a hex string. Okay, so that's challenge number 1, right? Which is just file header identification. So a common trope in CTF forensics challenges, right? So notice how right now it's been very easy going. If I give you mystery file.png, I can look at the front and it says PNG, right? Something nasty that I can do as a CTF challenge, I can remove the PNG header. So I can take the first few bytes of this file and I can just delete them. The rest of the file is still a valid PNG file, but the file command will not be able to identify it as a PNG file. So the challenge becomes you having to identify it based on other clues in the file. So what?
Deleting the header will also lose a lot of other content because since PNGs are further encoded on just basic pixel data, you can't just extract them from the beginning. You have to guess the dimensions, and then you also need to make sure that the checksum works.
Yeah.
It's a lot of fun.
So if I, for example, like, this is the full format, or not the full format, but this is the format of a PNG header. So we can see the corresponding bytes here. Every PNG file will start with 89, byte 89, PNG, and then a few bytes over here, right? Then the next few bytes tells me the size of the header, not mistaken, or the content data, one or the other. Then there's an identifier like IHDR, and then one of these fields will actually tell me the size of the PNG file. So you can imagine if I were to delete all of this information at the start of the file, and then I try and open it inside like an image viewer, right? The image viewer will not be able to open the PNG file as is, because it's missing all of this information. It's like if I were to give you an image that is of size of like 500 by 500, and I just don't tell you it's 500 by 500. So then you'll just be looking at like 250,000 bytes, and you don't know what is encoding, right? Because it could be 500 by 500 pixels, it could be 250 by 1,000 pixels, right? So that information is missing, and it can be turned into a challenge to try and figure out what it is. Okay, so that's challenge number 1. I'm going to skip to challenge number 4 because I think challenge number 3 will be annoying. Okay, challenge number 4 is a challenge to teach you guys about encodings. So I think we have covered this quite extensively throughout the last few days, but I'm just going to go through this for posterity so that you guys will see how to use CyberChef very easily. So if I dump all my bytes, well, all the binary stuff into CyberChef, so using my eyes, it tells me it's binary, so I'll do from binary. And then afterwards, I see what looks like a hex string. And CyberChef actually is able to identify that it's a hex string as well, right? So I don't even have to type from hex myself. I just press the magic wand, and it will identify from hex and put it in itself. And lastly, base64, yeah, it identifies that it's base64, so I can just press this button and there's the flag. The magic wand does not always give the correct output. So the magic wand is CyberChef's best guess at what it is. Sometimes you'll get it correct, sometimes you'll get it wrong. So it's not really AI. Instance when the suggestion mechanic can go wrong. right? Imagine I upload a file that has a fake PNG header. So maybe it's actually a JPEG, but I implant a PNG header at the start to mess with you all, right? When I throw it into CyberChef, it might think, oh, this is a PNG file, and then they'll try and render it as a PNG file, and then they'll fail because the actual data is a JPEG. So that is an example of misdirection, and that is something that can happen in CTF challenges as well. Okay, I'm waiting for the computer to connect. Are we back? Are we back? We're back. Okay, let's look at challenge number 5. So challenge number 5 gives us a JPEG file. I can open it in Photos. And this is a screenshot from the movie Uncle Goonby Who Can See His Past Lives, released in 2010. Can recall his past lives, yes, released in 2010. This is a Thai film. It's a really good movie. Anyways, the flag is somewhere in this file, but it is not immediately in this image, right? So you have to think, where can we store additional image for a file? So one way that you can do it in Windows, right, is to look at Properties and then Details. And then if I look at the details, there's a comment. There is a comment that actually has the flag in it. So this is a very, very simple challenge, but there's a lot more data that can be encoded in an image file. So take for example, right? If I were to use my phone and I were to take a photo. Let me try and make this easier for myself so that I can use less brain cells. Give me a moment. Guys, give me a moment. I'm looking for a challenge in an example.
Is there a skill-based foundation? Or is it hell?
What?
Or is it already in hell right now? Is it hell with a high school cap? It's always in hell with a high school cap.
Okay, wait, guys, give me 3 minutes. I have a CTF challenge that's on my phone. I need to get it off my phone so that I can show it to you all.
Is this one of the CTF challenges that you solved for the best thing? Wow. Didn't you win that one? Wow.
Oh my god. Oh my god. Ah! I have found it. Okay, how do I get the file from my phone onto the computer so I can show it to you all?
I'm going to blank the screen so that I can log into Telegram.
And I went to Star Vista too many times to count. And also I went for like 3 concerts
I
there.
just find the date that the picture was taken and then just cross-reference it to an actual concert that's happening at the same time.
Okay, so that is the correct line of thinking. So there might be more information attached to this image than is let on. So again, if we go on Windows we can just look at properties, then we can look at details, right? And we can actually see a lot more metadata this is called metadata, so it's like additional information tagged onto a file. We can see a lot more metadata than the image that's on. So we scroll down, we can see that there are GPS coordinates, and we can see the date that this file was taken, right? This image was taken. So, okay, this is one way to do it, right? Using properties. The thing is, the Windows properties tab is not super comprehensive. It doesn't have every single bit of metadata that can be encoded in a file. So an alternative that we can do, if you guys have Linux, which you should, this is the 5th day. If you still don't have Linux installed, I cannot save you, right? There is a tool that we can use called xftool. Now, this is not my WSL installation, so I do not have xftool installed, so I will install it right now. Xenon, what's your password? Where are they? Where are they? Paging, I need Xenon's password to install a program.
US, New York, Singapore. Is it November 5th?
Give me your password.
The password is Azazel.
It's Azazel? The password is Azazel. Okay. Okay, settle down, settle down. Settle down. I know it's funny. I laugh too. Ha. Okay, let's move on. So, EXIF tool. I can use EXIF tool and I can pass in the image. This JPEG. I can pass in the image and it will show me all of the relevant metadata as well. So this is everything that EXIF tool could find. And EXIF is just a format. It's a metadata format that is quite consistent, right? The exchangeable image file format. So your MP3s, your videos, your photos, more likely than not have EXIF metadata embedded in it. So one way you can view it is with EXIF tool. Another way you can view it is with the Windows Properties tab. And if you are extra lazy and you don't want to install anything, you can just go online and you can just upload the file. So if I do that, oh, see, skill issue. The website couldn't do it. So this is why we download tools and we don't rely on other people's websites. I mean, this one probably works. Let's upload it. This is not my computer. This is not my computer. If this was my computer, I would have known the password was Zazu just now. Anyways, see, this website's slow. In the time that it took for me, see, it didn't even work. In the time that it took for it to error out on me, I would have solved the challenge already by using EXIF tool. Okay, settle down. So I think my point is proven. So some other metadata that can be encoded in an image file, the make of your phone. So if you take a photo, so like Samsung is really notorious for this. If you take a photo of a Samsung phone and you leave the GPS data in, if you were to upload it to a site and it doesn't strip the metadata, it will be able to tell me the focal length, my f-stop on the camera. It will tell me how zoomed in I am. It will tell me my precise location. It will also tell me what my phone model is. It won't tell me when I bought it, but it will tell me when it was manufactured, right? So there's a lot of data that can be hidden in an image, and it is your job to get it out. Okay, so that's challenge number 5.
Oh, you can't use the online EXIF tool. Doesn't CyberChef have EXIF?
Maybe.
Cyber
I don't know, I don't care. So we've done challenge 1, we've done challenge 2, we've done challenge 4 and 5. Let's look at challenge number 3, which I think is the cringe one. Okay, challenge number 3 is the one that my friends on MacBooks cannot do. Because you need tools. So, challenge 3 is a disk image file, right? And when you are presented with a disk image, you will have to use image forensics tools for them. So, the one that we got you all to install is called Autopsy. There are alternatives, right? So like me, personally, I use this one called FTK Imager. This is a very good forensics disk image tool as well. So there's a lot of file formats for. Yeah, you could also. Okay, I will go through every method that I can think of off the top of my head to solve this challenge. Okay, there are many ways to approach image files, because the matter of the fact is, file formats are low-key alive, right? So, do you guys remember what a jar file is? What's a jar file again? Java archive, right? So the thing is, a jar file is run with the Java runtime, but secretly, a jar file is a zip file. You can unzip a jar file. This is true. Does anyone know what a docx file is? Microsoft Word document, right? Did you know that a Word document is also a zip file? This is true. I can unzip a Word document. I will show it to you right now. If I can find it. See? Personal statement. I'm gonna unzip it, dog. I'm not gonna open it. So, this file, right, is a Word document that I will not open because I respect the privacy of my friends, right? However, what if I were to make a copy of it? I'm gonna make a copy of it. I'm gonna call it like PS1 or something. I will make a copy of it and I will change it to a zip file, .zip. Now Windows will complain because I'm changing the file extension, but I can view it as a zip file and I can look at all the parts that make up a document. Huh? What? Right? So the truth is, if you remember just now, I was talking about doing hex dumps and stuff. If you do XXD on, so remember PS1 is a copy of the doc from just now. If you look at the header is PK. PK stands for many things. Pangkan, which is something I want to do. But PK is the file header for packs. Well, it's zip files, technically, right? So PK header. Zip, the zip file format. It comes from the guy's name, Phil Katz, meow, right? It doesn't actually stand for packed, I lied. So when you are presented with a disk image file, right? I know I said you have to use like FTK imager or autopsy to deal with it, but sometimes you can just take a stab, right? So let's go to see chow tree. What's it? Let's see what file says this is. So this tells me that it is NBR boot sector, right? It's a FAT32 file system. If I were to look at the headers of it, I can see MKFS FAT, so on and so forth. This is not a bootable disk. Now, we have a lot of magical programs nowadays like 7-zip, and 7-zip is actually able to... Do I have 7-zip on this? No, I don't. See, I don't have the tool, so I can't even show it to you. But if you have 7-zip, you can extract this. If you have an ISO file, ISO, usually that's what you use to install stuff, or you have it on a disk, you can also just unzip that trivially. So, lots of yapping, not a lot of doing. Let's solve this challenge, right? Oh, the hotkey? Seriously? What? Bro, I'm getting grief. My lesson is getting grief. Why doesn't it? I want to finish this, but I don't have autopsy on this laptop. Forgive me for the unpreparedness of my fellow trainer. I'll just finish this. I'm almost done. Wait, this is the last bit. This is the last bit. Oh my god. Oh my god, bro. Oh my god, bro. I have autopsy on my computer, right? I do. Guess we're switching computers. But I don't have the challenge, so now I have to download the challenge. Oh man. Okay, oh man. Can't believe I got rage baited live.
This guy got me. If I have one pickle for every person with rage before this session, I'll have 2 pickles, which is not a lot, but it's 2 and it's happened twice.
Oh my god, well, I haven't opened autopsy on my laptop either, so how do you like... That would take like 10 years to set it up. Oh
every
my god.
person rage outward. Autopsy.
Yeah, give me liberty, give me fires. Duplicate my stream and I'll retire. There we go. Okay. Oh, my cursor's like so slow right now. Okay. Guys, can I get your attention? I'm done getting rage baited. I can carry on. I need to download the challenge. Training announcements. Okay. Challenge 3.zip. Oh my, why is my mouse so slow? Hey, why the Wi-Fi so slow? Why everything so slow today? I'm just not having a good time today. Guys, Ocean Challenge, you can see what's in my downloads folder. If you can figure out what event I was involved in last week, you get nothing. Okay, finally, we can get started. So, autopsy. I'm gonna make a new case in autopsy. I'm gonna call it whatever. I'm gonna put it somewhere. Oh man, this PC. Let me just put it in my downloads folder. How about that? You ever think about that? Downloads. Challenge 2. Yeah, launch. Okay, so you don't really have to fill in any of this optional information because it says optional information, and optional things are things that do not need to be done.
That's true. White word.
So it's going to create the case database. So autopsy is very, very feature rich. That also means it's very, very slow. Oh, see, my thing's passing away in real time. Okay. I'm gonna go through this whole thing. So I'm adding a data source. And the data source will be the image file. So next, I've got a disk image. So I can just select the disk image. What's an orphan file? It means there's no parents. Like that, no, like that's just true. Like that's actually just true. Yeah, no, like it is a term in computing. If you have an orphan process, that means there's no parent process. If you have an orphan file, there's no parent. So I can pick the image file as my data source, and then I can go next. And then it will do some injection. So injection is the part where autopsy actually processes the data source. So these are all the things that we'll let it do, and then it's gonna process, and then it's done. It's added to the database. Yay! So, like I said, I don't know what this challenge is. The challenge author did not tell me what the challenge is either, so I am as blind as you all. Okay. Okay, so let's see what we can see in here. Data sources. Let's look in here, challenge tree.image, right? So we can see this is what is on the disk image. And we can see the disk image has a main.exe, very suspicious, right? So it's got an executable file. So if I had a more comprehensive disk, I could show you some other things. But basically, if you're given a case file, or you're given some evidence file, autopsy can help you find deleted files as well. So something to keep in mind, and this is actually like a cool little bit of information that you should carry with you for your whole life. When you delete a file on your computer, it isn't immediately deleted. All you do when you delete a file, like even when you go to CycleVin and you clear it, is it will just tell the system, yeah, the file doesn't exist. But sometimes the data is still there. It just tells the computer, oh, there's no data here, you can write over it, right? But in actuality, it's still there. So if you plug it into a program like Autopsy, sometimes your deleted files can still be read and can still be done. So that's why, like as a security measure, right? When you reset your phone, or when you like clear a hard drive to sell on Carousel or whatever, you need to zero it out. So you need to set every single bit of data to 0 as like the safest measure. That or you blow it up. So other things that I could be doing in Autopsy if I had a full image file, viewing OS accounts. So if I have an evidence file that has like Windows users on it and stuff, it can show me the user folders and all that. And data artifacts can get really cool. So like if I have, let's say, an image file that has Chrome history or has download history or something, it can show up. But in this case, we don't have anything of that sort because we just have a boring USB image. So some other things, some other neat things that you can see in Autopsy, you can see the metadata. So it can tell me what the hash of the image file is. It can tell me it was in the time zone. It can tell me the sector size. It can tell me it's a raw image. Okay, back to clicking into things. Click. So these are directories and files that we have. We've got main.exe, right, which is an executable file. What happens if I run it?
It'll delete your entire code. No, just give flat. But you need to run it in terminal.
Yeah, okay, cool. So if I have a file in Autopsy, I can export it, I can extract it. So like over here, I can extract main.exe. Now, most of the time, you shouldn't just anyhow extract things and run them, because sometimes those files are dangerous. But you trust us, and I trust the challenge center, so I will run the thing on my computer and hope it doesn't explode.
I put a bunch of malware in it, like so much, like a lot of malware. Like it's packed full to the brim with malware.
Okay, so I've extracted the file from Autopsy. Now I can go over to where I've extracted it to. Main.exe. Let me double click it. Are Windows rewind at me? No. Okay, so I double click it, I didn't see anything and it closed. Why? Any guesses why? Any guesses why I didn't see anything when I ran the program?
Because I wrote a bad job. That's true.
Any guesses? Is it corrupted? No, it's not corrupted. Fake headers? No. Well, not every exe program comes with a GUI. Not everything you can see in. Not everything you. Oh, help me. Not everything you can just see flat out, like on that computer when you run it. Sometimes things are console programs. So if I open in terminal instead, and I run the program in terminal, wow! It printed some text for me, and I can visit. I don't know what this image is. I can visit the link. Wow, that's the flag. That's the flag right there. And that's all the 5 current challenges solved.
It starts today.
Okay,
On the FTK users because we have a different.
so if you decide to use FTK Imager instead of Autopsy, because FTK Imager is faster and less cringe, right?
That is a cool jacket.
That's okay. In FTK Imager, you can add evidence items, and it's a similar process. In this case, we have an image file. Now we can just get the image. So I can add this in, and it does a lot less processing compared to Autopsy. Also, the text is a bit small, sorry. And again, so FTK Imager, this around, they actually managed to get a bit more metadata, so it can identify that this is a FAT32 USB drive that has no name. Yeah, that isn't. So FTK Imager is another way to view your files in order, like on an image file. And it's just faster, right? Because this only reads the image and shows whatever data is on it. It doesn't do any additional processing. So remember what I said, with Autopsy will help to get strings, will help to get passwords, will help to get deleted files, will help to get whatever stuff, because it will do ingestion for you. FTK Imager does not, so it's faster, but then you need to do a lot more digging yourself. But similarly, you can export files, extract files with FTK Imager, and you get the same result. So just to make sure that you guys are in the know, right? There are many different file extensions for image files that you can encounter. You've got ISOs, ISO file, not the international. So ISO files, right? In the good old days when everyone used CDs, right? That is what we had on our CDs. Another file format that you might encounter, right, is an AD1 file. So AD1 can only be read by FTK Imager. It is a proprietary evidence format. Another file format that you might encounter, an E01 file. So an E01 file is also another forensics file format. So all of these things can be opened in Autopsy and FTK Imager, and you can just view and explore them as if you are viewing any other computer's file system. So in the context of CTF challenges, right, most of the time when you are given an evidence case file, you have to simulate the process of digging for evidence in it, right? So for a bit of grounding, imagine that you are a police officer, right? Imagine you're a police officer, and you need to solve a crime, right? And you manage to get a hold of the laptop of a criminal. You do not want to just be clicking on that laptop and exploring the files on the laptop, because who knows, maybe there's a bomb, or maybe if you click around on the laptop too much, the laptop will delete itself or something, right? So what the cop would do is they would make a forensics image of the laptop, and then they would do the processing on their own computer. And what sort of information would you be looking for in a forensics disk? Like I said, passwords, history, cache, images, anything that can give more information as to what the person was doing on the laptop. So a specific example that has occurred recently, right? There's been a lot of assassinations that have been going on in the United States. There's been a lot of people killing each other in the United States. That happens a lot, right? And nowadays, people in the US, really young people in the US that commit crime, they like to talk to each other on Discord.gg, right? So they have Discord servers where they discuss and they plot their crimes and whatever. And police officers, when they get a hold of their laptops, will make evidence files, and actually Discord stores a lot of information on your computer. So even though we know Discord to just be like, oh, everything is on the Discord servers, whatever, right? It's on their side. But actually on your computer, and if you had to install Minecraft mods or Minecraft worlds or whatever, you're probably familiar with going to app data, right? You can see in the app data folder that there's a lot of stuff that Discord is storing in the computer alone, right? So local storage, level DB, LDB, these are all database files. So these database files actually contain a lot of information, and you can do some like cursory research on what's on it. So like Discord, forensics, artifacts, right? So even just doing some Googling, right? You can read other CTF write-ups or whatever, right? Oh, wow, it's lagging a lot. Ah, stop. So, I want to see the Discord example. So if I go to app data, roaming Discord, and then I go to my cache, and my cache data. So all of this here is data that Discord has cached on my computer, right? And some of these files, can it stop lagging? So all of these files contain some information inside, right? They don't have a file extension right now, but if I were to just open a random one in Notepad, stop, I want to open Notepad. Why's my computer lagging so much? Must be the air. Okay. So this is all just a whole bunch of bytes. Oh, nothing burger here. But there are programs that are able to interpret what this is. Okay, I'm trying to find a more practical example, but I can't think of anything off the top of my head. Oh man. Logs. Logs. Log files also give you information, right? So like, for example here, this, if I were to have a forensics file of my laptop, right? All of this information to do with my CPU, okay, my CPU is here. My monitor settings are here, right? My GPU, which is my onboard integrated graphics, the information is all here. So there's a lot of like little bits of information that you can get out of here. At least off the top of my head, for Discord in particular, when you type a message in Discord and you like type halfway, right, and you don't finish it, you know, like you can go to another page and you can come back to it and that text is still there, right? If you like type halfway. That text has to be stored somewhere. And actually it is stored somewhere in the Discord cache. So even your incomplete messages can be read after the fact, right? So your Discord logs, the images from Discord, I'm pretty sure Discord images are easier to find, but I'm worried if I show Discord images here, something might, I cannot guarantee that it will be safe. So, yeah. Lots of yapping. Hopefully you all understood a good chunk of that. So, at least in the context of CTFs, a lot of really bad CTFs, which is a lot of local CTFs, they like to set a lot of forensics challenges that require a lot of guessing. So, if you remember earlier with Wireshark, right, there are thousands of protocols under the sun that a computer could be networking with. And a lot of really bad CTF challenges will require you to find some super obscure protocol, or will make you sift through 100,000 packets to find a flag. Or sometimes they just give you an evidence file, and they're just like, yeah, can you find a Gmail of the guy that was using this computer? And then you will have to like dig through the entire evidence file just to find one Gmail account, right? Which is cringe. That's cringe and lame. So we aspire not to be cringe, so we have set non-cringe forensic challenges for you all. for tomorrow. Yeah, just to close off this part of training, forensics, unfortunately, is one of the more practical skills to come out of this workshop, because what we have taught so far sort of exists very much in abstract isolation from practical real-world applications, but digital forensics is very common and will continue to get more common as more and more of our digital footprint becomes more and more relevant to things like solving crime or mapping out advertising data. So if you were to enter cybersecurity and do cybersecurity as a job, digital forensics is an entire line. It's like a whole mini sub-industry of its own that you guys can explore. Because people want to get information, like out of phones, out of computers, out of servers, and be able to analyze it. So that's all. That's all for forensics. I hope the content was more digestible compared to yesterday's, or the day prior, or the day before that, or the day before that. So yeah, it is 11:53. Our lunch is here. What we are going to be doing for the rest of the day, after lunch, we will be walking through some of the homework that we've given you across the week. So we'll be looking at a few select challenges based on your feedback, and then we will close off training. Tangy, Beijing for Tangy. Beijing for my fellow organizer, so that they can settle lunch.
I didn't want to
Yeah. Okay, so when we create a post, this is the internal function that's being called when we create a post. First it checks if we are logged in, so that's no issue. We are logged in. Then we need to supply a title. So there's this check here that checks if title is none. Right? And then now we are doing it for URL. If not sanitized URL, what does this do? We don't know yet. We will see what it does later. But before we check the sanitization, before we check the sanitization, let's look at this one. It visits our URL. Right? That's quite interesting. So it's quite similar to the XSS challenge. There's a bot that's visiting our URL, but in this case we don't want XSS. We want to get out of the file, right? So visit URL is a component it's a function from our util module, which is inside web util.py. Okay, so visit URL. Visit URL. It doesn't do anything. Like it just does URL open and it opens the link, right? So how can we use this to read files on the file system? Let's look at URL open. URL open, we don't know what it does yet, but we can try. So we can just open a new Python shell and then check out this one. So Python 3. And URL.request.URL open. So URL lit.url request. Okay, let's first try. Just put a URL in like this. Let's see what it returns. So okay, it returns us this client object. I don't know what a client object is, but in the source code, it takes that client object, it calls the read method on it. So try it again, .read. And okay, it gives us, it looks like the HTML of the website, that we just put in, right? What if we can, okay, so this URL open, we already know that it gives us the ability to visit websites. But URLs are not limited to websites only. We can read files, we can read other things. URLs are not just for websites, right? And if you look at the list of so-called URL schemes, especially a very long list, you can go to URI schemes. Yeah. Right, and the very first one is actually the file URI scheme file. So that's one step closer. Yeah, we know we need to use this URL thing to read our file. And let's try to do that. Let's try to do that, but not in the challenge. We do it in the Python shell. So the way we use this file URL is we put file // and then followed by the file path. So if you want to read from the root file path, it will be extra slash. So //etc/password. And you can see it lets you read the file. It lets you read the file. Right? You can try some other file like if you don't have a PC password in your system, some other file in your system. Yeah. But we know that this allows us to read files already. But there's an issue. And the issue is in sanitized URL. Remember, sanitized URL is called before visit URL. So if we open this, it does 3 checks. It checks if the domain is localhost. So you can see the check not localhost, that's the localhost check. It checks the domain itself for certain rules, we'll look at that later, and check the scheme. Scheme, right? We're already using the scheme, we're modifying the scheme from HTTP to file. So let's look at scheme first. scheme is the most important for now. And it's very long. So it's a very long list of schemes. If you will check if your scheme is in this list, it's a very long list. Power is in here. Right? So power is here. What does it do? What does it do? If your scheme is in this list, it returns false. So our file scheme is in this list or this tuple of banned URI schemes. So if we were to go to the challenge itself and we just put in a URL like file, like the same as just now, file etc password, it will actually return invalid URL because we are getting blocked by sanitized URL. So that's a problem. We need to fix this, right? Okay. Checks. Okay. How are we obtaining the scheme actually? Let's look at the scheme. So if you go back up, oh sorry, it's not there. The scheme is passed to checks. Is taking it from URL path. So what we do is we pass the string, the URL string, right? We pass it to URL parse, which is from URL. We extract the scheme from this URL parse object. So could there possibly be some vulnerability here in the URL parsing itself, right? That allows us to bypass, or we can construct a URL such that the URL scheme that's returned by URL parse is not found. But when we pass it to URL open, it's actually found. So because we are not checking the URL, so we are doing some transformation of the URL and then passing it to check scheme. Right? So there could possibly be some vulnerability in this URL parse here. So let's go and search for URL parse. URL parse. URL parse. Oh, there is a vulnerability. CVE. Oh, this is not one. Okay, URL parse vulnerability scheme. I think scheme. Yeah, if you search something like this, it should. Okay, there are very long list of vulnerabilities actually. Yeah. There's one specific one, I think this could be a possible one. Bypassing URL blacklisting using blank in Python URL lib library. So that's what I want to do. We want to bypass the blacklist. The blacklist being the file, the URI scheme blacklist. And here we go. URL lib.parse break the URL strings into components like this. So this is the URL parse. This parse result here, right? This is the object that we're dealing with. And we don't want the scheme here to be fouled. If the scheme here is fouled, then we are going to fail the check. Right? But I can see the second line here. All they did is they added a space. They added a space in front of the URL. And suddenly the scheme just becomes an empty string, right? And then the path becomes space http://example.com. And that is exactly what we're going to use for our challenge. So the first part of the challenge, all you need to do is just add a space in front of this file reading URL. That's all. Add a space. It's going to bypass the check. Here you go. Oh, there's one more thing. Okay, before I do this one, right? We forgot there are two more checks that we're doing. Check not locals and check domain. So both of these. Okay, the first one deals with the host name parameter, but it's nothing much because all we are doing is we are checking if the host name resolves to 127.0.0.1 or 0.0.0. if it resolves to either of those two, then return false. So our our URL should not resolve to this. Let's get the next one, check domain. Check domain must also return true. Oh, and this is very long. There's a very long there are a lot of stuff going on here. So it's checking for host name. It's really doing a regex check on the link itself. And yeah. Let's start from the start. Okay, so this regex is quite complicated actually. Okay, let's start from here. So the first one is this one. This is the first part it's checking. It's checking if okay, I will not use ChatGPT because Amy is not here.
Oh, we did that right now.
Guys, it's okay to use ChatGPT. It's okay to use ChatGPT.
We did that. I was thinking. Oh, we did that. We did that. Wait, gang.
I can't stop you from using ChatGPT during the competition. Like, if you use it for trading, it's your loss. But if you use it during the competition, it's your win.
We can use ChatGPT, you know why? Because you're cool. Okay, but the real reason is because regex is quite complicated so like it's not beneficial for us to go and look through one by one what the regex is doing. We want ChatGPT to give us a summary first, then we can take a look. So okay, the very first part, right? The scheme, the first regex that's being passed through. This caret symbol represents the start of the string. Okay, so start of the string, and then a dot means any character. So we match any character afterwards, and then after that it allows you to supply any lowercase a to z, any digit 0 to 9, dot, plus, and minus. Yeah. So it allows you to supply any of these characters afterwards. So it means that something like this is a valid scheme in this this URL checker. Something like this. So some character in front. So let's say like A, or maybe tilde, and then A to Z, so ASDF, 1, 2, 3, 4, something like that. And this is a valid scheme in our regex. Right. Okay, then let's move on. Then the next part, user path authentication. Not very important for us because basically what this is checking is the there's this special like user name and password. Okay, I won't say that. But there's a field in URLs where you can specify your username and password. So we also put this in regex to pass it through. Next one we check the domain. So this is now after the username and password, we're going to check the domain. And for the domain, we have 3 rejectors. The first one is the IPv4 check. Second one is the IPv6. Third one is the hostname check. That is. Okay, and then check the port, check the resource path, and that's all. Okay, so our URL, why we need to go through this, right? It's because our URL needs to pass all 3 of the checks in order to return at the bottom of this, right? Sanitized URL. In order for sanitized URL to return true, all 3 checks need to pass. And because this check domain actually it expects our URL to contain a domain, right? This payload is not going to work. If you just put etc password, there is no domain in this because we need to have a domain here, somewhere here. I can prove it to you. So let's copy. I'm going to copy the 3 checking functions over to my Python shell. Okay, so let's pass a URL to sanitize URL. Then let's say we did the file. Okay, we do this but with the space, right? The space was to bypass the. Wait, they're not important. And try again. Okay, false. The first one we try is without the space. This one returns false. With a space, returns false as well. And now we know that because of the this false is happening because of the check domain thing that's going on here. But how do we specify domain? Because we're just reading from localhost, right? I mean, we're reading from the local file storage hub. How can we specify a domain for a file? So let's go and Google file URI scheme domain. So we just Google this. Yeah, we can go here. You can actually put a host. The host is the FQDN of the system that we want to read the file from, and this is like it's like an artifact from older usages of this file URL. And if this host path is omitted, or this host domain is omitted, we take it to be localhost. So now we know our original this one, right? When there is no domain specified here, it defaults to localhost, right? And you can try that. So our URL open, we use URL. Here the request. So what I want to do here is instead of letting it be empty, we put a localhost and see if it can read. Okay, we can read. Now there's one last check to pass. If we pass this to sanitize URL, we will see that it still fails. It still fails. This is because of the last check. Check not localhost. In this case, it is localhost. Because this socket will get host by name, it will resolve localhost. But actually, you can bypass it quite easily. Okay, let me go try with bypassing. So socket.get host by name. Let's see what this does. Socket.get host by name. It's another Python function. And what it does is basically it resolves the final IP. It looks up the DNS route for the final IP that your domain points to. Get host by name. Get host. Get host by name. Yeah. Translate your host name to IPv4 address format. So what it's doing is resolving our IP to our domain to our IP. So let's try it. Let's see if changing the capitalization of localhost affects this. Okay, it doesn't. Let's see that. Get host by name. Let's Google online. Okay, I can't find anything here. Okay, let's see first. Let's see if this payload actually works on our remote. So, sorry, just with localhost. Let's just see if this works. So, before we try anything else, copy this, go to our remotes, paste it. If it works, ooh, it works. Okay, I guess the verbose check wasn't necessary. Okay, so why exactly is working? I'm not sure, but it works. Okay, so you can read the etc password. So now to get the first part of the flag, we just need to change this etc password to the flag path, and the flag path we can find from the Docker file, right? So if you are, we'll be using this thing called Docker in our challenges. So you need to be familiar with reading like Docker files. It's basically like a way to set up a mini like VM or like mini machine for your challenge. So over here you see this copy dot. Copy dot means copy everything in the local in your current directory into the current directory of the Docker file. And the current directory of the Docker file is this app directory. So our flag right, will be found at /app/flag1.txt. That's exactly where it's going from. So we change our payload here. Localhost app flag _1.txt. Okay, that's the first part of flag. Okay, now the second part of flag is inside. If we look at the README, right, it's actually in the database. So we won't be dealing with. Okay, we come back to the web one later. Let's look at the database first. And database is using HDB. So HDB, under the DB schema, you can see that. Oh, the flag was not supposed to be here. Okay, the flag is here, but I will show. This is the second part of flag, but it's not supposed to be here. Okay, I'll show you how to get it from the remote. So, yeah, the flag is there. Okay, but we weren't supposed to get the flag from here. We're supposed to get the flag from this URL querying thing. So, this HDB, right, we can actually query. You see, this is using this extension called HQL HTTP. So this suggests that we can actually query the database using HTTP. So we can go and Google HQL HTTP query. HQL over HTTP, yeah. Right. Yeah, using extension HQL HTTP. So our instance can receive HQL queries over host name, port, and then the branch name /HQL. And then how we can query, we can use GET request like this. So GET request passes the fields as query parameters, the query string, and then variables global. Those are not important. So that's an example of a query. We can see a query here. It's not the same as SQL. SQL is slightly different syntax than HQL. But in this case, you can see this query, select something. So person is the table, select table. And then this one means select all fields from the table. And then here we can filter by something. So actually all we need to do is, in this case, the flag is not in the table, it's a global variable. So later on we can go and find out how to query global variables in HQL. But first, we need to construct our requests such that we can, our URL such that we can issue requests to the HTTP instance. So we go back to post. Create. Okay. So according to the docs, right, it's HTTP. And then the host. How do we find the host? We need to go back to Docker. So there's this other file called docker compose.yaml. It actually defines all the different parts of the challenge they are working together. So the web part of the challenge is on one machine. The database is on another machine or another like VM. So in this Docker Compose, right, the host name is also just the name of the container itself, the host name of each container. So let's say we are in the web container, we want to issue a request to the DB container, right? We can just visit it via like HTTP DB and then the port that we want to visit on. Yeah, so that's how we're going to do it. But there's another problem. So let's say we just do DB, right? Like this. Let's find the port first. The port. HTTP port. TCP port, distance on 565. See if it's looking for HTTP. I think it's probably the same. Yeah, it's probably the same. Okay, so let's say we try to issue a request 5656 / so back in the box, right? We need to, so we have host name, we have port already. Now branch name / HQL. So what is the branch name? Honestly, I also don't know, I forgot already. Yeah, I can't forgot the branch name. I don't know. I said it like 3 years ago. Don't be just cheat. I'm just gonna cheat. I'm a bit lazy to solve. Let me show you where this challenge is from. Okay, I took too much time for this challenge, unfortunately. But I want to show you guys that. Okay, you know what? I'm gonna leave the second part for you guys to do. Okay, I'm just gonna go through Next.js really quickly. Next.js is very easy. So the idea is you want to construct a query from your. Wait, but technically I solved it already because the flag was here. What? The flag was here. Second part of the flag is here. So I solved it already. Woohoo! Okay, next one is Next.js. Next.js is very easy. This is the Next.js challenge. Sorry? No, it's port 505.
Why do you find the second flag again?
The second flag is under /HDB /DB schema /default.esdl. That's not the intended, but you know what? I found the best thing. Okay, let me show you again. From the this HDB DB schema default.esdl. That's not the intended, but I guess it's there. I don't know why it's there. Whatever. Okay, the next one is very easy. Let me download this. It's gonna take like 5 minutes. The intended wasn't to find it there. The intended was to use the query to query.
Yeah.
Okay, this one is very easy. So, if we go inside pages, right, you can see there's a page called flag.js, and then if we have this not state.admin is equal to true, right, then we can view the flag. If not, we cannot view the flag. So let's just go over to our thing here. Just go to slash. So we are not admin, so we cannot see. But actually, everything is loaded in client side. So if we just go and search the inspect element, right? You'll be able to find the flag somewhere here. Okay. Under sources. It's shaking because of the CSS. It's quite ugly. I don't know why it is. Let's see that. Okay, this is the no. There's a JavaScript file that we are requesting from the server. It literally just contains our flags. Because everything is done on the client side. So yeah, that's all for this one. Okay. Let me start. So from the start, we know that the flag is found at /flag. Because we have a /flag.js here. This pages /flag.js. So if we visit this page, right, our this dot state is equal to false because it's set here. It's equal to false. So if we are not the admin, right, it won't return us a flag. It will just return us no. So it will return us no like this. But if we look inside the network tab, if you look inside the network tab, there's a bunch of JavaScript files that are being requested here. All these JavaScript files. All of them is labeled flag e50something.js. It's under the network tab. Network tab. So you need to open the network tab first, then you refresh the page. So once you're on this page here, you just refresh the page. It will log all the requests that you need to yeah. And then you go to flag.js. You just find the flag here. Okay. For the last challenge, the part RC one. I'll just go through very quickly. I won't demo how to solve it, but basically this challenge, what we want you to do is we want you to be able to find CVEs. Find CVEs based on the configuration of the web app. So in this specific challenge, the web app is using a vulnerable version of Pub.js, 3.0.2. Then if you just Google Pub 3.0.2 exploit, you actually find my CVE.
Lucas
Yeah, this is the CVE that I found. So if you go to my blog, you can actually find the POC there.
This guy is really Linux doesn't do the inspect, so
Okay, we're gonna move on.
Okay, we're going to move on to crypto. Sorry for wasting too much time on the first challenge. Where's our crypto guys?
Yes. Where are my crypto trainers? Behind you.
I had the time to leave it and check.
You didn't bring up.
Yeah.
Okay.
Okay, thank you guys.
You can clap.
Encore.
Okay, wait. Zazu, thank you. Like shift to your right. Your left. Now look into the camera. Lean forward.
Okay, so
Just use Menti again. Oh, the Menti mirror. Yeah, make a Menti for them to vote on what they want to cover. How fast you think you can teach?
Quite fast, but is there changes that need me to go through? I thought we go through.
I mean, no, again, we poll them for what they
okay,
want to cover.
so I think like day 2 we can't give you all 6 challenges, and we also give you all the source scripts for 6 of them later that day. So is there any challenge you guys would want us to personally go through? Even if we've gone through already, just let us know if there's any challenges you want us to go through. Yeah.
Yeah, make a Menti poll or something.
That's our fascinating creatures.
Huh? Really scared. No, because it was already open. It was like, why are you using it? No, it's only my open. How do you make a menu? How do I make one? Oh, make your own. Oh, this is Oh yeah.
Okay, I will give you all 25 minutes.
Okay. Why do you have a time limit?
So that I can go through web and Kieran can go through the phone.
Okay.
I mean 30 minutes. 30 minutes.
What should we prioritize going forward? Well-being, improve company culture, retain talent.
How do you increase more options? Oh, alright. Let me look at the Blah stream record.
Okay. Alright, so you will notice that there's like 8 challenges here, but we can't give you only 6 of them. So yeah, I'll just make a mentee for you all to vote which challenge you guys want us to go through or re-go through.
Wait, who voted this already?
Just like the screen.
Okay, it's nice. How do you erase the votes?
I think it starts.
Yeah. Yeah.
Okay, so we have the 6 challenges here. Our -2 and -1 for this. In the meantime, if there's any crypto challenge you guys would want us to do, just like vote something. If you all are okay and you all would rather we give the time to ref or phone, just don't vote and yeah. Wait, let me just add a how do I add a vote? Oh, okay, there we go. I'm going to add a vote saying that I'm group pass to ref.
Double and give it to the next person.
Huh?
Double it and give it to the next person.
Yep, there we go. We'll just go through the challenge with the most number of votes in the meantime.
Oh.
There's a vote, there's an option that's asking.
No one published.
Wait, you find that straight. Yes.
There we go. No one can see the other challenges.
Right. No one can see the other challenges. Oh my gosh, the challenge name Roblox. I wonder what that could be.
So we won't be going through this because these are very scary. Yeah, scary RAM is very scary. And I don't want to cover it.
I like the sound part. AA.5, AAA.5.
I have no idea what this is about.
This is your confidant.
Oh yeah, it is. Oh, it's not. Oh, okay.
Okay. Alright, I'm going to check on the poll. We have 6 votes for backcorrection 1, so I'll go through that, and then if there's time, I'll go through integrity. Afterwards, we'll pass time to ref. I think that sounds good, so I'll just start going through it. Alright, so I'm going to cover backcorrection. So in backcorrection, you essentially, alright, I can understand the reason why people want us to cover this, because this was based on a crypto scheme that we didn't really cover in the slides in the end because of time constraints and because people were stuck in number theory. So this is an implementation of what we call the Diffie-Hellman key exchange. Those at the back, can you guys see the code clear enough, or do you need me to zoom in more? Okay. Yes. Right. Is this good enough or deeper? Okay, can. Alright. So the general idea here is that this has this is one of those challenges whereby there's code and then there's an output behind it. So the output behind it is basically the code having been run. So you have the output of the code and then you have the code itself. So this is what the heck is going on? So in this challenge, there is a from secret import flag. So for those who are wondering, when you see this is basically our way of saying that we have a flag that we hide. We don't want you to know the flag, because the whole point of trying to find the flag in the first place. So this doesn't mean that there's a secret library with a flag. This just means that there's a flag from somewhere else. So we can just kind of like change this as something like, for example, flag equals to, I believe it's fine. So I'm just gonna do like test flag, something like that. We can just do something like this. Regardless, as we move through, we are going to try and trace what happens to our flag, and we see that it is directly used in the encryption here that uses AES encryption to encrypt the flag. Recall that AES is a very secure form of encryption, which means that you shouldn't try to find the key. Or if you have the key, then you get the flag. So if we look at the key, we see that it is long 2 bytes of a shared key, and this shared key is basically the output of this math thing that's going on. So the first thing that happens is that there is some sort of public key, which is G to the power of a private value, and we do this modulo some value P. So far so good? And then the shared key itself is derived by doing this value to the power of the same private key modulo P. So we have like SK equals, this SK is the shared key, is server public to the power of our private modulo P. So we see that we are given P, we are given G, we are given the public key over here, which is G to the power of private modulo P, as well as the server public value here. And the idea is that we have to figure out what the shared key is so that we can derive the AES key to decrypt the flag. And you can see that our parameters are here. So this is basically what we call the Diffie-Hellman key exchange. So in traditional Diffie-Hellman, Diffie-Hellman is an asymmetric key exchange that involves 2 users, Alice and Bob. So Alice and Bob have their own private keys and public keys. But the general idea is that basically the shared key is some generator to the power of what we call AB, where A is the private value of Alice and B is the private value of Bob, and this is done modulo P. So server public is basically Bob's public key, which is G to the power of some unknown B modulo P. And then this public key is our public key, or Alice's public key, which is G to the power of our private value modulo P. The security here lies in that the discrete log problem, which is given G to the power of X, it is very hard to derive the exponent X, unless certain conditions are met, where you have attacks like Polyhellman, baby step giant step. Those are algorithms that I would encourage you all to look up yourselves. There may or may not be challenges in qualifiers that do require knowledge of them. Yeah. But in our case here, we notice that to get this shared key, we basically need to figure out what this private key value is. Because we have server public, we have key, we just don't know what private key is. And we see that private key is a rand range of 1 to 1 million. And rand range is a function from the random library. So this library, or random, basically generates random numbers. And rand range, if you hover away on VS Code, it chooses a random value from start to stop. So that means it's a random number from 1 to 1 million. So if you think about it, there's only 1 million possible options for the private key. So we can just brute force it directly. So if we go to the solution, what we basically do is we take the values and the encrypted value, we converted the encrypted value from the hash string to a bytes format, and then we basically just brute force the private key. So for private key in range 0 to 1 million, we compute g to the power of private key model p, and then we just check if this value is the public key that we have. Because recall, not only do we need to find the shared key, we know that the public key is g to the power of some number from 1 to 1 million, or p. Because we are given the public key value over here, therefore we can use it to kind of like just check until we find the right value. Once we find the right value, we print the value and we compute the shared key. Then we just derive the AES key and we use it to decrypt the flag. So if you run it, it's very fast. It takes like less than a second to brute through 1 million cases. You understand that Python is actually quite fast. So even like basic things like putting from 1 to 1 million, you can do it super quickly. So if you run this code, you'll see that it just says found this value followed by the flag once you decrypt it. And I can demo it for you guys here, where this should run quite fast. I'm not sure why it's taking quite a while for. Yeah, there. So it just says I found the private key, which is 527138, and then the flag is just here. Any questions? Yes. You. I mean, because we know that private key is from 1 to 1 million, there is a very small range for us to brute force. Because like Python can cover like a million things in very short time, so we just directly brute force it with Python. This challenge is just meant for you all to basically be familiar with the fact that you can use Python to brute force things directly, and that sometimes you don't have to find something, especially when that something can be hard to find, and that instead you can just use brute force directly to brute through all possible cases.
Does this not make sense? If it makes sense, thumbs up. If it doesn't make sense, thumbs down. Can we get a show of hands from the audience? Okay, well, thumbs up, so.
Yes.
So, big thumbs up.
Sorry?
So like AES, if AES is basically, I kind of covered it during the crypto part on day 2. It's a block cipher, and the idea is that it is generally secure. So if you have a ciphertext, you cannot get the plaintext of the key directly. You don't have enough information. So the whole point of the challenge is that to understand that this is unbreakable. So to find a way to decrypt the flag, we need to find the AES key. So the idea is that from the logic should go from, oh, I see the flag is being encrypted here, and I know it's encrypted with this key value. So I need to find the key value. So I look back, I will kind of work backwards. I need to find this shared key value, and then I kind of work back. So I need server public, private key, P. And we know for a fact that in the output, we have server public and P, but we don't have the private key. Because just to reiterate, flag is here, I need to reproduce the AES, I need the key. This AES key requires this shared key. This shared key requires 3 values. I know 2 of the 3 values. Private key I don't know. So I go back further, and we see that private key is some random number from 1 to 1 million. So the solution is to just brute and see which private key works. Yeah.
What property of P? What property is P?
So the reason why it's very hard to find the exponent, right, is because with model P there's a wraparound. So once you go past P, it goes back to 0. So it's not a value that keeps increasing.
Right. I'm just gonna go back to the Mentimeter. I think we have time to cover one more challenge. So if you all want me to cover another challenge, you guys can feel free to just vote. We can do the challenges that we didn't cover. Do you guys want us to cover reuse? Since I think it's one of the challenges that myself and Azizo didn't cover on the second day. If you all want, just vote for reuse, I guess. If not, I'll just recover integrity again.
Discrete logarithm for like e minus 1.
The order t minus 1. If it's factorizable, you can put it in.
But the exponent is 1.
Yes.
In that case, we might. In that case, we might. The factor of e minus 1.
Wait, no, I need to have some Okay, meantime, is there any questions for backtraction? If not, I can move on and look at something else instead. There we go. This is better. This doesn't spoil anything. It just has the source for everything. Nice. Right. Yes. Sorry? Which? Yeah. Like G is 5, P is this value. What do you mean by like what is that? It's just part of how you implement diffie-Hellman key exchange. So you can look up the algorithm, you can look up how the key exchange operates, and then you can see that P is just any prime, P is any generator. But of course, if the prime fits certain criteria, it is insecure, and I believe that this is actually insecure. So I can't say much, but I can let you know that if my parameter key is random from 1 to P, right, you can actually break the system. Just an FYI. Like, the params here are quite insecure, but I won't elaborate on it because it may or may not appear during the qualifier now.
That's crazy.
Okay, I'm going to look back at the poll. Alright, I see that there's only like one vote for reuse, so we might not cover it, but I'll just like give a quick rundown. Judging from the votes, I guess it's okay. Is it okay if I skip integrity and I just like briefly touch on reuse and then so that we cover all the challenges and then we can pass to RE? Is everyone okay with that? Okay, can. Alright, so just for reference, right, integrity is basically AES malleability. So the source script is basically revolves around just using the XOR operation to XOR the ciphertext with the message, with the modified message, and then sending it to the server. That's basically what's going on over here. Yeah. And we will move on to cover reuse, I believe. So in reuse.py, we see that it is an RSA challenge. How do I know it's an RSA? Because encrypt has this very familiar number and then there's this very familiar encryption function. Regardless, if we look through, we see that our primes are just 256-bit primes and we generate 5 of them. Then whenever we encrypt a message, we convert it to a number and then we take a random prime in this range and we multiply it with another random prime in this range. So choice is imported from random. So choice is a function in random that given a list or a collection of objects, it picks a random object inside. So as a quick, like very fast demonstration for random, if I just go to Python, and I need to like zoom in here. If I do, for example, what the heck was that? From random import choice, and let's say I have a list of let's say 1, 2, 3, 4, and I just do choice of list, we see that as I keep running it, it gets like random values from like 1 to 4. Yeah, so it's kind of like very random in terms of like what it is getting. Yeah. And just for reference, oh, I need to like move up. And just for reference, if I want to do like rand range, and I do rand range, let's say 1 to 100, I basically get random values between 1 and 100 over here. It just generates random values. Yeah.
Constraints.
And also, every time I call it, it usually will give a different number. So in our case, our n is just some random prime in among 5 primes multiplied by another random prime. All good so far with the code? Okay, then as we move down, we see that there are 3 messages. We have hello, welcome to encryption service. Here are some example plain text, and then flag. What's flag? It is a redacted flag. This is not a flag, this is just something that we use as a send-in or a send-by. The actual flag is being encrypted because all the messages are encrypted. And encryption gives the modulus n, which is some random p and q, as well as the encrypted output. So here we see that each of these outputs is a tuple, or basically it's like it has 2 elements. There's a modulus and there's a ciphertext C. So the reason behind how to solve this challenge is that remember that we cannot solve RSA unless we can factorize n. And in here, because n is 1 of 5 primes multiplied by 1 of 5 primes, the chances of this modulus and this modulus being used having the same prime factor is quite high. I believe the probability that this flag doesn't contain any prime from here or any prime from here is probably like less than 20%.
0 actually, because of pigeonhole.
Is it actually?
You're choosing 6 things from 5.
Yeah. So by pigeonhole principle, don't worry about it. Google yourself. So by the pigeonhole principle, this modulus will at least share 1 common prime. No, why?
Yes, what? Like
Yes, what?
If 2,
N1 is P1, P2, N2 is P1, P2, N3 is P3, P4. This repeats.
Ooh.
Yes. Okay, but anyways.
Whatever.
Okay, yeah, so the probability that this modulus doesn't share a prime factor with the rest is very low. So we can assume that this modulus has a prime factor that is being shared with these 2. And for those who are wondering, because I saw this in the ticket, why we only focus on this modulus? Because this is used in encrypting the flag. Do we care about recovering these 2 messages? No, we don't, because we don't need to care about them. So we are just going to do GCD, the greatest common divisor, of this value, which is the flag modulus, with any of these 2 values. And let me just go to my source script for this. You will see that when we label them as N1, C1 is the ciphertext, N1 is the modulus, you will see that actually, so I kind of just printed GCD on everything to see what it is, and we find that N2 and N3 have a shared prime factor. Like if you run this code, you'll see that P is not 1. Therefore, once we get our prime of N3, we derive our Q, and then we just derive phi and D, and then we just convert it, and then we just do RSA decryption as normal, and we see the flag here, negative recovers previous primes. So I'll just do a quick run it, and you can see that, yep, it finds it over here. Yeah.
Okay, can I double check, right? How many of you all remember what GCD does? Okay, see, none of them remember what? Like half of them. Okay, so GCD calculates the greatest common divisor of 2 different numbers. Let me test y'all, okay? The people who raise their hands. The GCD of 7 and 9 is what? Why? Both are prime numbers? You want to say that again? Okay. 7 is prime. Okay, if 7 is prime, then GCD of 7 and everything should be 1 also, right? So GCD of 7 and 14 is what? Okay, so I'm sensing a problem here. We didn't check. Y'all don't have a good grasp what GCD is actually doing. Then we ask you to solve the challenge, you're also doing it. Okay, so I test you all again. One last one, You promise me you get this one mark and we move on. Okay. GCD of 15 and 20 is what? 1, 5 and 2, 0. Oh my god. Oh my god, bro. GCD, okay. One last question. Okay, how one now? Okay. 13 and 169. Why? 169 or what?
169 squared.
Okay. So do you remember why RSA is difficult to crack in normal terms? Why? Huh? Why? Okay, very large primes, right? But the goal is we want to recover the very large primes, right? So if you have GCD, and I would say GCD is very fast, even if you have really big numbers, it can compute like that, can compute it. Anyways, so now do you understand why GCD is useful here? Okay, explain it to me then. Mr. GCD of 7 and 14 is 2. Explain it to me. I want to know. No, try your best, gently, try your best. Don't choke. Try your best.
What does GCD stand for?
What does GCD stand for? Great question. Highest common factor. Okay, that works also. So, right, we have n, right? N is equal to p times q, but p is very large, q is very large. We have some other number, p times some other nonsense. Okay, so n is equal to p times q, your other nonsense, p times some other nonsense. If you GCD n with the some other nonsense, what do you get? P. Does everyone understand why we get P? Explain.
Because since the primes are using GCD of both of them is P multiplied by some other number, so our GCD is
Can I get the whiteboard? Aiyo.
correct what?
I mean, it's correct, but I feel like nobody is following.
No, you just have to rephrase it.
Okay.
No, Haki, no, and if we bring out the whiteboard, it's gonna be too much trouble. Bring out the whiteboard is too much trouble.
Okay.
Yeah, so as Emmy or Kane or whoever has been saying, right? If I have a number that is made up of two primes, right? Two primes, right? So n equals to p times q. How many factors does it have?
N equals to p times q. P and q are both prime. How many factors does n have?
How many factors do I have? 4. What are those 4?
1, P, Q, P times Q.
True. Okay. Now I have another number that is p times r, right? Where r is also a prime number. How many factors does it have? 4. And what are those 4?
1, P, R, P times R.
Okay, true. Right? So between these two, let's say, and more often than not, almost definitely, right? Okay, here's the trivial case actually. What if q and r are equal? What are these two numbers if q and r are equal? They are the same. So like whatever, right? But more often than not, because your prime numbers are massive, q and r are not the same, right? So if q and r are not the same, and then I take the greatest common divisor or the highest common factor, right? That is the easier to interpret term. Highest common factor. What's the highest common factor between these two? P, right? I've only got 4 factors to choose from for either of them, and the common one between them is P. So if I get the GCD of N1 and N2 and I get P, right? Then what can I do? I can take this and I can divide it by P. And what do I get? Get Q if I divide N1 by P. If I divide N2 by P, what do I get? R. And if I have P and I have Q, what can I do with RSA? I can break it. I can crack it. Right? Because remember, in order to get your decryption key for RSA, you need to know P and you need to know Q, so that you can calculate P minus 1 times Q minus 1. So that is the crux of this challenge. The whole point of this challenge is to identify that you can use GCD, or your highest common factor, to factorize the numbers. Is this clearer? Clearer across the board? Yes? Okay, thank you. You see, the challenge itself, right? Okay, why is it that we have two numbers that share P in this challenge?
Why is it? Because you only have 5 primes you're using, right?
you're generating you're doing encryption 3 times. So you need to have 6 primes, right? So you're definitely going to repeat one of the primes somehow.
Yeah,
I specifically ran this code until N3 had a prime factor repeater with either N1 or N2, okay? It took like 3 times.
yeah, so you see the thing about these sort of challenges, right, where there's a bit of RNG, a bit of randomness, you can run them multiple times until the randomness works in your favor, right? You have infinite lottery tickets. Well, as much time as you have to play the lottery, that is. So use that to your advantage.
Yeah, and I think with that view, wait, anyone have any questions?
Can't gamble, right? We can't gamble.
You have a question?
Minus.
Okay.
Minus can't gamble.
Alright, then
It is time for you to redeem yourselves. One final GCD question. Okay, lock in, okay? What's the GCD of 7 and 48? CD after class. Okay, then moving on.
Okay guys, I hope you guys had fun remembering how math works. I hope you guys like math.
You said 48, right? You said 48, right?
7 and 40. 7, 40. 7, 5, 1.
I'm
Big
sorry,
fan of the word profile.
Sounds more spoon here. I'm gonna ruin his camera.
Not like the Americans, you know. The guys would say GCD of 7 and 14.
Okay guys, another Mentimeter. We have brought out another Mentimeter has hit the projector.
That's what he said.
These are the ref challenges that I gave y'all on Wednesday. This is not all of them because I'm too lazy to cover some of them. So please vote on what you want me to cover.
LeBron James, scream if you love reverse engineering.
The Menti code is this is the Menti code. 6430 7936. Where's 167? Oh man.
What do you guys want?
This is tough. I want to see double digits. I want to see double-digit votes. There are so many people in this room. More. Give me liberty, give me fire, vote on my Mentimeter or I'll retire. Okay, the moment I get 20 votes on something. No, wait, how many people do I have in this room? Like 50? 40 something? Okay, I need to get at least 23 votes on something.
So only can vote once.
You can only vote once? Yeah, then you vote once, bro. Stop. No voting fraud. Stop the steal.
Echo is going up steadily one by one.
Hey, good job.
You guys are gonna make him also be a what? You don't do it wrong.
I cannot make a political joke because this is being live streamed and our sponsors will get angry at me. Okay, I hit the bar. Okay, this is kind of the late one, but it's okay. So by popular demand, I will be going to snore, and supercomputer. Yay! Can we get some claps for snore? Okay, so for a bit of context, right, I stole this challenge. Okay, so let's take a look at it real quick. Does anyone in this room play Osu? Yeah, for my Osu players, is this familiar at all? Snore? You
Oh yeah,
snore. This is a big Osu map. If you want to know why the challenge is called snore, it's because I stole it from the Osu CTF. Yeah, it's an Osu CTF. Okay, anyways. Do I have everyone's attention? Can the people at the back see the screen? Is this no? Too small? Okay. Hey, can someone give me a mouse? I need a mouse. I'm in desperate need of a mouse.
Why did you use that?
No, my trackpad sucks. I don't want to use that. Okay, so let's go part by part with this challenge. So I think, yeah, I did. So I sent out an announcement like on Wednesday because well, not a lot, but enough people asked, how are we even supposed to get started with this challenge, right? Because the script that you all have should terminate like here, right? Where it just ends off with print bits to string, ank flag or hex, and then these bytes. So the first thing that I want you all to try is to actually interact with the challenge. So similar to the crypto challenges and the web challenges and everything, right? The distribution opens flag.txt, but the flag.txt that I give you is not the actual flag, right? This is a fake flag. So what you're supposed to do is you're supposed to figure out what the actual flag should go in flag.txt, so that when I run this script, it will produce the output that's in this comment. So for example, right now, with what I have, cd source. So if I run the program as is, Python 3, oops. If I run it as is, these are the bytes that I get at the end, right? Because this is what happens when I run the program with my nonsense flag and with my own parameters, right? So we want to work backwards from this one. Okay, let's quickly look at what each of the functions inside this program is doing. Let's look at the low-hanging fruit, string to bits, right? Guys, remember, strings are characters. Characters are numbers. Numbers are bytes. Bytes are bits. True. Yes, 1 byte is 8 bits. Good job. You don't get a cookie. So, let's take a look at what the string to bits function does. So let me close the bar on the side. You guys can see my you guys can see the Python rebel at the bottom, right? So I'm going to paste in the function. I want to paste in the function without problems. One function. I need a mouse so bad.
Yeah.
Danke schön. Okay, I'm safe. Let me copy this.
Oh yeah, and also FYI, the mouse button do copy and paste. The side mouse buttons.
Okay, so I have pasted the function into my Python console, so I can run the function now. Right? So observe the following. If I run string to bits on, and this has to be a byte string, okay? A byte string. So you guys would have seen this yesterday during Cone as well. There is a difference between these two. So if I have a string called like testing, right? This is a string in Python, correct? Everyone agrees this is a string? Then if I were to take the first element of this string, it will give me the character t. And t is also a string, right? T is actually, if I do type, I think it's type. Yes. So the first character of testing, the letter T, is a string. However, if I define testing with a B at the front, so if I do B testing like this is a byte string. So a byte string will actually, if I index it, right, if I take the first element of a byte string, it gives me the numeric representation of that letter instead. So you see, spot the difference, right? If I do byte string testing, first element, I get 116. If I do actual string, first element, I get T. And if I convert 116 to a character, I get P. So the string to bits function that I have over here, it actually only works on byte strings. So if I were to apply this to a byte string, testing, then it will give me a bunch of ones and zeros. And what these ones and zeros are, they are the bits that make up the bytes, which make up the numbers, which make up the characters, which make up the string. Wow, right? And we have another function, bits to string. Any guesses what this does? Exactly, it converts the bits to string. So if I do bits to string, of string to bits of testing, I just get it back. Wow, these are functions that are inverses of each other. Okay, great. Now we can look at snore, the snore function. So the snore function takes in two variables, pt bits. PT, what is PT short for? Plain text. Okay, and what is key short for? It's not short for anything, it's just key. So what it does is, okay, anyone know what zip does? It's not zipping up the file, it's not compressing it. A zip is just a nice thing in Python where if I have two lists and I want to step through the lists at the same time, I can just do that by zipping them together. So, for example, right, let's do something practical. Let me define pt bits to be string to bits of 1. Okay, and I will make t bits equal string to bits of what's a test. Okay, so the size of these two arrays are equal. Does everyone agree? Yes, because the length of the things are the same. So this is 32 bits because it's 4 characters, 4 bytes. 4 bytes is 32 bits. That's true, right? And same goes with my key. So if I look at PT bits, it's like 0111, 011110. If I look at key bits, it's like 0111, 0100, so on and so forth. If I zip them together, so if I do this for PT bit, blah 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 blah, right? And then I print, print. You see, it has paired up my numbers. So it pairs this and this, it pairs this and this, it pairs this and this, this and this, this and this, so on and so forth. Right? It's pairing them together. So remember, when we perform bitwise operations between two numbers, right? We go bit by bit. We match the bits together and we apply the operation to it. Right? Agreeable? That is what this code is doing. So we are going bit by bit in PT bits and key bits, and we are applying the snore gate to the paired together bits. So now we figured out the snore function is applying the snore gate bit by bit between PT bits and key bits. Now, what is the snore gate? If 0 and 0, I get 1. If 0 and 1, I get 0. If 1 and 0, I get 0. Else, and implicitly this is if 1 and 1, I get 1. Guys, do we remember what the XOR gate is? Yes, right? Remember the XOR gate, if they are the same, it's 0. If they are different, it's 1. What's going on here? If they're the same, it's 1. And if they are different, it's 0. So this is just the XOR gate but inverted. However, even though we have inverted the XOR gate, the same properties still hold. So remember the funny thing where if I have some number and I XOR it against 0, I just get the number back, right? If I do it with the SNOR gate, instead of getting the number back, I just get the inverted version of the number. Then if I do, so okay, wait, let's be practical. Let's be practical. Let's actually showcase this. Right. Copying the SNOR gate, copying the SNOR function, right? Okay, so if I do SNOR of 0, 0, 0, 0 with 0, 1, 0, 1. My 0, 1, 0, 1 has turned into 1, 0, 1, 0. Now if both of them are the same, then there is, okay, wait. If both of them are the same, instead of turning to 0, remember with XOR, if they're both the same, what would happen usually is it turns to 0, right? But this time around, instead of turning to 0, it turns into all 1s. But our properties still hold. So if I snore twice with the same thing, so if I do snore, 1, 1, 1, 1. Okay, I need to put down the microphone. See, notice this is the thing that I repeated, right? And this is my initial. My initial and my final are the same. So actually, this is the same as XORing twice, right? So now we have figured out the SNOR gate is just an XOR gate but inverted. And in spite of that inversion, my XOR thing still does the same thing. So like if I XOR twice, or in this case if I SNOR twice, I will get back my original result.
You basically just done it once, but you wrote it 3 times.
Yeah, so remember if you snore 2 times, it's the same as snoring 0 times, right? So actually, this is a bit of scamming, right? This function, this line of code, is equivalent to just doing snore once. So these 2 lines are actually equivalent in logic. Okay, so now we have an understanding of the snore function, we have an understanding of the snore gate, and we understand that our code has been scamming us, and when it does snore 3 times, it's actually only doing it 1 time, because doing snore twice is the same as doing it 0 times. That's modular arithmetic. So, how do we actually get to solving, right? Remember, our flags. What do our flags in the BlahajCTF start with? Blahaj, right? So that means the first 4 characters of the flag must always be B-L-A-H, Blah. So, okay, so in the actual code that this program runs, it first generates a random key that is 4 bytes long, and then it repeats it a bunch of times, right? This is a quirk in Python. I can take a byte string or a set of bytes and I can multiply it by a number, and then we repeat it that number of times. I think you might have seen this in code yesterday. So now we know that we have a 4-byte key that is repeated over and over and over, right? So if we can get the first 4 bytes of the key, we can get the entire key, correct? Are we in agreement here? Yes. Okay. And then remember, we know what the first 4 characters of our flag has to be. It has to be B-L-A-H, right? So if I know that it's B-L-A-H, and it's being snored, I'm going to use the XOR parrot instead of like, whatever, right? It's just simple. So it's blah, right? And it's going to get snored against some key. If I XOR it again by blah, what do I get? I get the key, right? So we can apply this directly. So this is the reverse operation, right? We start at the end. So at the end, this is the flag that is being output in hex, right? And then we convert it from hex back into bytes, back into a byte string. And then we convert the bytes to bits. Okay, so next, we get blah, right? We get blah's representation in bits. Okay, cool, great. So, as we have just determined, if we take the first 4 bytes, if we take the first 4 bytes of our output, and we snore it against blah, we will get the first 4 bytes of the key. Okay, this is a typo, I guess. First 4 key bytes. I will get the first 4 bytes of the key. Agreed? Are we in agreement here? Thumbs up, thumbs down? Thumbs up, thumbs down? Okay, I see some thumbs ups. I know it's been a long day. But just hang on. Just bear with me here. Right? So now that we have the first 4 bytes of the key, we can just repeat the operation. We can multiply it so that we get the correct length, and then we can just snore it one more time. So we snore our output with our key that we now know, and we should get the flag. So if I were to actually run this, if I run the script now that I've added all these extra numbers, oh my god, item 3, not bad. Ta-da! You get the flag at the very end. Yeah. So that's snore. This is considered easy. This is the easy difficulty for what you'll be seeing tomorrow. Okay, so that's the first challenge I'm going to walk through. The next one I'm going to walk through is going to be supercomputer. Okay, let's look at supercomputer. So, supercomputer, right? Supercomputer, you're given an exe file called supercomputer checker. Okay, wait, before I continue, can I get everyone to stand? Can I get everyone in the room to stand? Okay, I'm sorry. I know, maybe your teachers have done this. I know it sucks, but it helps, I swear. Okay, you guys stand up also. Come, it's been a long day of sitting down and looking at computer screens. Let's all stand.
You could have said that like 4 days ago.
Yeah. Okay, everybody, I want you all to breathe in, and I want you all to hold your breath. Come, breathe in. Now breathe out. Okay, let's do that 2 more times. Let's breathe in. And let's breathe out. Okay, last one. Breathe in. And breathe out. Okay. Wow. My back pain. My neck pain, my legs pain, my everything pain. Okay, you guys can sit down now. Okay, thank you for hearing me. Yes, it's in the Google Drive. Okay, sick. Now we can actually cover this challenge, and then we can take an extended break before we finish up training. Okay, so for everyone that has this challenge downloaded, right? We are given an exe file called supercomputer checker. We can run it, and then it just dies. Oh man, right? Let's run it in terminal. Maybe we'll have better luck if we run it in the terminal. So, after running the program, right, it tells me this space check failed, terminating check sequence. So I didn't provide the challenge description, but your intuition should tell you, okay, this program is performing some checks. It's checking for debugger, whatever that is. Actually, you should know what that is. I taught you all what that is on Wednesday. Then it checks for your disk space, and then it says it fails. So maybe in order to solve this challenge and get the flag, I need all of my checks to pass, right? But how do I even get started? This is an exe file. This isn't a Python file. This isn't like C or something. It's an exe. So let's do a bit of reconnaissance first before we throw this into Ghidra. Because remember, when you get an exe file or an ELF file, usually your instinct is to throw it into a decompiler, like Ghidra. But this file is kind of big. This file is like 15.5 kilobytes, which is decently large, right? And if you throw this into Ghidra, you're not going to get really good output. Why? Let's run file first. Running file on this, it tells me, yes, it's a PE32 executable, and it tells me it's a .NET assembly, right? And if I were to do strings on it, if I were to do strings, it tells me .NET Framework 4.8, right? Okay, interesting. What is .NET assembly? Mono .NET assembly. So we consult Google, and it tells me, oh, it's C#. Okay, it's .NET. It's like some sort of subclass. And also, people are talking about disassembling them. Oh, interesting. Right, so .NET decompiler, maybe. Search .NET decompiler. And then I see, oh, free .NET decompiler and assembly browser. IL5.NET decompiler with support, blah, 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 right? Oh, cool. How do I decompile a .NET exe into readable C# source from us 17 years ago? Yeah, people have been asking this for pretty long. Some of you weren't born when this question was asked, right?
All of us.
So,
the JC1 and JC2 students were like 1 year old.
So yeah, like we've got a few answers here, and they say, oh, you can use ILSpy, you can use DNSpy, you can use whatever. So maybe let's listen to them and let's use ILSpy. Okay, ILSpy. So I've got ILSpy. I've already opened the thing there before. I'll just show some data. Okay, so I have this program called ILSpy. I have no clue what to do with it. So let me just take the exe file and drop it in and see what happens. Okay, for my friends at the back, is this way too small? Is this better? Okay, wait, you still can't see the stuff on the left, so I'll just use magnifier. Okay, so I managed to import my .NET assembly into ILSpy, which is a tool that I just Googled that says it will help me, right? Now I'll start clicking randomly until I get an answer. So I start clicking. Okay. Check the program. That sounds good. Program sounds like it would have to program, right? And I see main. Oh, it's the main function. Hey, nice, right? And in the main function, I have my checks, my debugger check, VM check, whatever. Okay, sure. So I can see the source code of this program very explicitly, right? Banner.show, what is that function doing? It is printing that computer that we see at the start, right? Then it says running environment checks. Yeah, that's true. When I ran the program, when I ran the program, it did show me that text, running environment checks. True, right? And then you can see here, it has a list and it adds a bunch of checks to it, shuffles that list, and then it checks whether it passes. So checks pass or fail, right? And then it prints, if it fails, it'll exit, which is what we've noticed, and if it passes, it carries on. Okay, cool. And if we manage to pass all the checks, so if we fail any check, it will exit us from the program, right? By calling environment.exit. If we pass all of the checks, it will call workflow engine.execute. So let's see what this function is. It looks like it's a function that calls validate internals and verify. What is validate internals? Okay, it checks the date. Sure. Let's see what verify is. So you see, the thing about reverse engineering, right? Especially when you're looking at just like code as is, you don't need everything to work. All you need to know is, like, you can just pretend it works, right? So like, this if statement, maybe this check will fail, but I don't care. I'm gonna say the check passes, and then I'll look at the next thing. Okay, then it does hash code. It gets a hash code, and it checks whether it's divisible by 2, and it checks if the environment count. I don't know what that means. I don't care. I'm just gonna assume I pass the check, and I look at the next thing. Okay, finalization complete. So if I manage to pass all those checks, it will have shown this to me. And it will check the date, it will check whether the time was 2359, and then it will have printed the flag that the time was 2359. I don't need to wait until 2359. I can look at the code now, right? So I click on print flag, and then we can see it would have run payload manager.fetch, put that output to raw, sanitize input, put it into input, decrypt buffer, put it into stage, run post-processing, put it into text, and then print the text. Oh my god, okay, let's look at each stage. So, what does payload manager.fetch do? It just returns this string. Okay, let's take that down. This looks like a suspiciously useful string. I'm gonna put this in Notepad. Okay, so now we know that raw, string raw. Now we know string raw is equal to this thing, based off the function that we just looked at, right? Now let's look at the next thing. String input equals transform pipeline.sanitize input raw. So what does sanitize input do? Oh, all it does is it trims. Remove all leading and trailing occurrence of a set character. Oh, so it removes the equal from the front and the back. So we can just do that, because I can read.
Really?
And it says string input. So now we know string input will equal to this. Okay, so far so good, we're following. Then decrypt buffer. So string stage is decrypt buffer on input. And what is it doing? It is, oh my god, it's our best friend, the XOR operation. So it is taking each byte, and it's performing XOR against cipher key. And cipher key is the bytes of the string ref tools. Okay, let's keep this in mind for a moment, because I'm lazy, right? If you look at run post-processing, for some reason, it XORs against cipher key again. So if I XOR against cipher key once, and I XOR against cipher key again, what do I get? I get the thing that I started with. So that means this intermediate step was completely useless, right? So the output of array here is still going to be the same string that we were looking at just now, right? The XOR with cipher key has done nothing. And lastly, it does from base 64 string. Oh what? Base 64, I know what that is. Let's go to CyberChef. Actually, I'm too lazy to open CyberChef. I'm going to open like Python terminal. Python. Oh, so don't be reliant on tools, because what you can do here is you can import base 64, because that is a thing you can do in Python. And you can do base 64 dot b64 decode. No, let's go. Okay, b64 decode. Then let me take the thing. Aha! There we go, that's the flag. I stole this challenge also. I stole this from Lag and Crash. It's a CTF that ran earlier this year that I didn't even play. Someone told me that they had a .NET challenge, so I just stole it. I don't know who Kairos is. They're the challenge author for the original one. So shout out Kairos. Shout out Kairos. Sorry for stealing your challenge. But yeah. So as we can see, right, the crux of this challenge was figuring out that it was a .NET assembly, finding the correct tool to disassemble .NET, throwing it into the decompiler for it, and then reading the code to understand what the program is doing. So this falls under the source retrieval category of web challenges, which is why I put it in the source retrieval folder. And that is how you solve supercomputer. Okay, any questions? Did anyone lose anyone along the way? I didn't pause. Yes? Yes, IELTS is not the only decompiler you can use for .NET. So a more powerful decompiler for .NET is actually dnSpy. Something cool about dnSpy compared to IELTS, right? And I use this for this challenge, right? Is in dnSpy. So just now we were looking at the decompilation, right? We were just looking at the decompilation. But sometimes when you're doing reverse engineering, you want to be able to change what the program is doing, right? So like just now I was saying, oh, for all of this stuff, we just assume that the checks pass, right? So if we go back to like supercomputer program name, right? Execute. So we were just assuming if flag, right? But in dnSpy, something that I can do in dnSpy that I can't do in IELTS, which is really powerful, I can just right click and edit it. So I can literally just, instead of doing if flag, I can just delete the if. I can just delete the if, recompile the program. I can export it, and then I can run it, and then it's like that if statement was never there, right? So this is something really powerful that's really useful when you're dealing with .NET assemblies as well. What I use this for when I was putting this in training was I went to the fetch function and I changed the string that was originally here. Because the original string was for lag and crash, so I just changed it to put my own text there. Because I can do that. Yeah, so dnSpy, that is the more powerful alternative to IELTS, right? And according to this Stack Overflow article that is older than almost all of you, right? You can use Reflector, you can use JetBrains, the JetBrains one. You can use the .peek. .peek is also quite good. Yeah, I've used it before, it's not bad, right? So yeah, any other questions? Any other questions for this challenge?
Okay, I got a question for you all then. Listening comprehension, question 1. What kind of binary is the supercompiler binary? Is it A, raw assembly, B, compiled C, D, C, .NET, or D, none of the above? What is the question? What is the answer? Please shade in the OAS with 2B pencil. No, but what is the answer though? What is the answer? C, how you know? Huh? How you know?
What was the first step that I did? Using strings, right? And using file. So keep those utilities in mind. We also just use this just now for forensics, right? This is very useful. If you don't know what file you're looking at, sometimes the computer will tell you.
Yeah, it says mono.NET assembly.
Yeah. Okay, file, strings, very powerful things. You got any other questions?
Do I have any other questions? I don't think I have any other questions. Okay, I guess question 2. Can you use the .NET decompiler for just like any random program you can find?
No.
Why not?
It's got to use
Huh?
.NET
.NET file with .NET compiler, okay. Let's say I get some C program, I compile it. Can I get such a good decompilation using any random decompiler or cannot? Because the decompilation you get from a .NET binary is very good, right? You got all the nonsense. Nonsense. Let's see the nonsense. This is very good nonsense, you got all the nonsense here. It's very clear. Of course like.
So the thing is, on Wednesday I taught you all how to use Gitra, right? Gitra is the more general decompiler in this case, but it is not optimized for dealing with .NET. So let's see what happens if I drop it into Gitra. Okay, also this goes both ways. So just now we said .NET decompiler to use for .NET binaries, right? What happens if I take a binary that isn't .NET? What happens then, right? And I drop it into a .NET decompiler. Any guesses what will happen? It's not going to work. So if I take a different exe file and I drop it in, you see, it just immediately tells me PE file does not contain any managed metadata. So that's the decompiler telling me it doesn't know how to interpret this, and then it doesn't give me any usable output. So back to Ghidra. So if I import supercomputer into Ghidra, right? So like let's say I didn't do file, I didn't do strings, I didn't do any work to try and figure out what sort of exe file it is, right? And I just blindly put it into Ghidra. Firstly, it takes a while because it's like a decently large file. Also, my computer is slow. So if I analyze, okay, I know it's a bit small. Now let's magnify. So you see, it's taking quite a while to do all the decompilation. And when it's done, right, if I look at the decompilation output, oh man, you see, even though intuitively you would think, oh, from entry, I go to main. This should be the main function, right? But this is actually a call to an external library. This is a call to the MS Core DLL Core exe main function. So I can't even see it. Like, I can't even see the decompilation output, trivially like that. I can see some of the functions, right? Like I can see the names of the functions, but I can't, like it doesn't decompile it for me even, right? Because it says right here, it's .NET CLR managed code. Because here's the thing, on Wednesday I taught you all assembly, right? And I said assembly assembles down to machine code. The machine code being x86-64 assembly. .NET also has assembly, but its opcodes or the instructions that it encodes are completely different. So Ghidra doesn't know how to interpret it. This is not x86-64. This is .NET's own intermediate representation. So if I Google .NET assembly opcodes, hopefully I can get the result to show. Not useful for what I want to show. Assembly and .NET. Yeah, not useful, it doesn't show me the thing. Anyways, my point still stands. The assembly that is used in .NET is not the same assembly that we see in most of our usual, air quotes, usual exe programs. So Ghidra straight up doesn't know what to do with it. If I look at the main function, I got nothing, right? So thankfully Ghidra is smart enough to tell me that it's .NET CLR managed code, so it gives me more of a clue of how to move forward. And if I look at the strings in the program, I can also see a lot of strings that have to do with .NET. So like I can see I can see assembly version, it tells me the assembly version. We've got this big XML, which is what we saw just now. We've got mscore.dll. If you Google that, you will probably get a bit of an idea of what it is. Microsoft Corporation. Right. So, in conclusion, you cannot use Ghidra to decompile a .NET assembly. You have to use a specialized tool to decompile it, right? However, even when you toss it into Ghidra, you will still get a clue. You will still get some ideas on how to move forward. But you can completely sidestep that by using other tools to perform reconnaissance, like file or strings. Okay, everyone clear? Everyone clear on this? So I will be setting challenges that may or may not involve decompilation with Ghidra, and may or may not involve decompilation with other tools that are not Ghidra. And it is your job tomorrow to go to google.com, that is google.com, and you will type into the prompt, how do I decompile this program? Edge. Microsoft Edge is not a search engine, it's a browser.
Bing.com.
Yeah, if you use Bing.com or Google or Microsoft Copilot, you should give up.
This is unrelated, right? But while I was looking around, I saw some of yours' default browsers are Yahoo. This means you have malware. You have adware. I'm serious. No, I'm serious. There is you installed something that made your default search engine Yahoo, and you have adware Yahoo. So we're going to figure that out. Exactly.
So it is 3:05. It's 3:05 p.m.
Samuel, where's Div Zero?
Okay, we're gonna take a short break. There's supposed to be a sponsor that will come and talk to you all for a bit, but all in all, okay, when that speaker comes, I want you all to give them your full attention, right? But for the time being, I've got Miss Kai, Mrs. Miss. Okay, I've got Miss Kai at the back. She's from CSA, right? That's one of our sponsors, so you can tell from the fact that it's on the shirt, right? She can answer questions. You can ask her what CSA is, if you have no clue what CSA is. You can ask her what CSA does in terms of cybersecurity in Singapore. You can ask her if you can get a job once you finish, I don't know, once you graduate. So it's free time now, right? For a while, it's about 30 to 40 minutes of free time until the other sponsor comes to talk. So, 5 minutes. Okay, for the next 5 minutes, you can talk to Ms. Kai first, but then the next sponsor will come and talk to us. And then after that, you can continue talking to CSA. And then we will conclude training.
I think you've been through a lot of months. I think I'm bouncing back.
Why don't you force them to go to the sponsor?
Is that the toilet card?
Hey guys.
Hello. Hi.
Okay, focus up now.
Hi everyone. Okay, I'm just gonna do a very quick introduction about Division 0. Anybody knows what's this 0? Okay, then you come and share. Just kidding. So basically, my name is Anna. So I'm at a crew at this 0, and I'm part of most of the initiatives. And it's really a cybersecurity community where most of us are actually volunteers, and we bring together like people who are interested in cyber. A lot of practitioners come for our events. So here are some of the things that we work on. Mostly we do a lot of meetups, workshops. We also do a lot of youth development. I'll share a bit more a bit later. We also have different special interest groups, which we call quarters. And we actually run a few conferences. We have SynCon and also StanCon. Not sure whether you guys know about it. And a few CapDev projects, as well as some awareness things. So over here mainly it's a link tree, which I encourage you to visit because it has a link to all of our socials and whatever announcements that we have. We also do meetups, which is mostly powered by our no-hats quarters. So they do have a separate Discord and a separate account as well, but we do kind of work together because we're kind of part of the same community in that sense. So for you, actually we have this conference called StanCon. I'm not sure what the dates will be for next year. You can check out their website, follow the No Hats page as well, and see when they will update. We also work with different competitions. Here are some of the different CTFs that are mostly run by students across different tertiary institutions. So on the international stage, we also do something called the Global Cybersecurity Camp, and next year we are going to Vietnam. And each year we will select about 5 to 6 students to attend this camp. And we also represent Team Asia, Team ASEAN at the International Cybersecurity Challenge, and most recently we had it in Japan. Next year it will be in Australia. So those who are selected to play for the team are actually covered for most of their expenses there. And this year we actually created something new. It's called the Singapore Cybersecurity Camp, because for GCC we only can send 5 to 6 students. So we really want to bring the experience to more students in Singapore. It happened around September this year. I'm not sure when it will be run next year, but probably a similar time frame. So over the next 2 slides, I'm going to flash like 2 QRs. One is for GCC, one is for SEC. So for this, our call for students are actually now open. Based on history, most of the students are from junior college, poly, or university, but we had a rare few who were still in secondary school, but quite rare now. So for those who are interested, you can still apply. If you have done really well in the application and you feel like you're suitable for this, we will reach out to you. The review should happen sometime in early Jan, and those who are shortlisted for interviews will be contacted for an interview in the middle of January. And the actual camp itself will happen in early March from 2 to 6 in Ho Chi Minh. So this next one is actually a link to the Telegram group for SEC. So whenever the team does run the camp or have any updates on workshops that they plan to do, they will also announce via the Telegram group. And on the next part, these are some of the quarters that we currently have. Of course, no hats, and we have a career quarter. Track modeling quarter started this year as well. Women quarter, we are trying to put together a badge life quarter. We also already have a work warranty quarter and a car security quarter. So a lot of these events that this year runs, majority of them are free to participate. So if you want to come for any of the events, you can just follow us on the meetup.com page and follow the instructions on how to sign up for each of them. But mostly it should be a Google form that you need to fill in. Alright, so over here you can see over there the first one, InfoSec in the City SimCon. So that is our flagship conference organized by Zero year on year. Usually it's held in May each year, but because next year DevCon Singapore is coming, and it will happen on 30th of April, I think. So because of the proximity in the dates, we are looking at another date possibly in the later part of the year. So if you're interested in that, we do have student tickets. You can follow us on our social media as well. And the rest of it are just the different conferences that we are actually partners with. So I'm not sure whether you all saw our post before, but actually tomorrow we are holding Hacksmith, and it's a 24 hours hackathon where teams of 1 to 3 come together to build security tools. And it's our 6th edition this year. If you're interested, I'm not sure whether it's still open, but if you're really keen, you can just talk to me later. I will talk to the team. And we also have something called the Shell Gym, where it is led by this guy called KK, and he does like trainings for workshops, which range from very basic know-hows to more complicated stuff that probably will help you in your journey if you're taking OSCP or any of the certificates. We are also working on something called the Cyberstorm Center, but it's still mostly work in progress, so not much details as of now. Oh, and last but not least, we're actually putting together something called a Void Deck. So if you know Void Deck is HTTP, and then we have a Void Deck. And the idea is to come together and to share knowledge, share things that we know, and together to put together this like hackathon for Singapore. So that's about all that I have for what this year currently does. If you have any questions, you can ask me after this. Thank you.
things that I'm not liable for, right? I realize I did not screen this at any point up until today, but we have to say this, right? We have taught you all a lot to do with cybersecurity, and unfortunately, a lot of cybersecurity, a lot of the defense stuff can also be used for attacking. So everything that we teach, that we've taught, right, all the tools that you use for reverse engineering or binary exploitation or web exploitation, right? You can only use it when people give you permission to use them. So on Saturday, for the competition, you have the permission to whack our websites, to whack our programs. But if you get caught trying to whack your school website, trying to reverse engineer like your exam anti-cheat or whatever, I cannot save you already. I cannot save you. Because if you do that, that is a crime. That is a crime. So don't do crime. Crime is bad. Okay. So I wanted to take some time to talk to you guys a bit about the point of all of this. Right? So you all have come here for the last 5 days to listen to us yet about a bunch of different topics. But why? Okay, so the thing about CTFs, right, that a lot of people forget and a lot of people don't emphasize is that these are gamified versions and abstractions of real-world cybersecurity. So when we come up with a CTF challenge, right, that's why we split it into categories, like web, crypto, rev, phone, forensics, OSINT, right? Because we want you to focus on a specific aspect of cybersecurity each time you play each of these challenges and hone your skills in that, right? So it creates a sort of focused search space. Because like if we just hand you a website with 20 billion things to look at, right? How are you supposed to know what you need to find out or what you need to look at, right? So the CTF challenge narrows that space and gives you something to look at, right? And a lot of the things that you learn in CTFs are actually like applicable in real-world cybersecurity. It's just in real-world systems, there's a lot more moving parts. So the analogy, this is a real-world system, right, with all the gears and all the different moving parts. And this is us. We take out one gear so that you guys can look at it in the CTF, right? What a stellar analogy. So some applicable use cases, right? CVE hunting, right? Like this is a CVE that came out yesterday for React server functions. It's quite crazy. There are millions of devices and servers and websites that use React, and the exploit that accomplishes this RCE is a combination of things that you can learn through CTFs. It's a prototype pollution attack. That's a web exploitation concept. And for the prototype pollution to succeed, it has to apply some overlapping concepts from code, because you are doing some metadata faking, you are doing some chunk overlapping, right? And obviously, in order to get to the crux of how this exploit even came to be, it requires a bit of reverse engineering in order to understand what the functions are, what they are doing, how to piece it all together. Cryptography is left out here, right? Unfortunately, crypto in most real-world applications, I mean, some companies roll their own crypto, so yes, applicable, but maybe a bit less. Yes, you will find cryptography more in research and academic areas. However, cryptography is still ubiquitous and very important, right? All our websites use RSA to do your HTTPS, right? Your banking institutions use cryptography all the time. So it's a really, really important field. This printer over here, this is the Brother printer, right? This was pwned in the recent pwn to own at Ireland. And this was pwned by some employees of Star Labs, which is a vulnerability research laboratory in Singapore, right? They hire a lot of CTF players because CTF players know what they're doing when it comes to binary exploitation. One of them is our dear friend Chirag Pai, right? And they managed to hack this printer to make it do all sorts of funny things, right? These are blogs that are written by some of the trainers here, right? Like Lucas Samizoratan, right? Or Kieran Fernchai, that's me. That's Azazi Zazo, that's our TA, Amelia K, whatever you want to call her, right? And a lot of the content that we learn from CTFs, a lot of the techniques that we learn, right, get dumped in a box, right? And this can get huge, right? Like these sort of hacks and these sort of vulnerabilities and the research that goes around it, it's a big, really important thing, right? For example, that same phone when someone was supposed to show a 0-click WhatsApp vulnerability, which they didn't end up doing. They didn't end up showcasing it because it's worth way more than $1 million. Okay, so now we've spent like a whole week learning how to do different categories in CTFs and the concepts in them. The thing is, you don't need to understand everything from the last 5 days. So CTFs are usually played as a team, right? Unless, who's the guy playing solo? You're playing solo, Power. Good luck, have fun, right? In most instances, right, CTFs are played as a team, maybe teams of 4, teams of 5, teams of 6, teams of 20, teams of 50, right? And you don't have to do every category, right? Like my specialization is in reverse engineering. That's what I've been doing for the last year or two, right? Lucas is particularly good at binary exploitation and web. Kieran too, right? David, wherever he disappeared to, his focus is cryptography, right? So it's perfectly normal if you didn't understand everything from the last 5 days. But hopefully the last 5 days have given you a taste of each category and you can figure out which one you find most fun and most interesting, then you can then spend more time learning on your own accord. So like to elaborate, this is the team that I play for, right? Slice now. So you can see all of us only cover like 2 or 3 categories each, right? But we play as one big team during competitions and then we split the work accordingly. Okay, where, when, who, how do you play more CTFs? How do you get more into CTFs? Okay, I know we brought up Pico CTF a lot, right? This is very, very good for beginners to get their hands dirty initially. There's this website called CTF Time, where any CTFs that are running like within the next month or 2, right, they will put up they'll put up there on CTF Time and they'll be like, okay, there's a CTF this Saturday being run by this organization and you can play online, etc., right? So this is for playing international CTFs. For local CTFs, just keep your eyes peeled and your ears open, right? Through organizations like Div Zero, Building Blocks, Blahaj, right? We put out advertisements and stuff for all the local CTFs that are running. And you can just try your hand at local CTFs if you're applicable as well. The best way to learn for CTFs is just to keep trying, right? There is no one-size-fits-all solution. There is no 50-day course that will take you from 0 to 0, right? We tried our best this week, but obviously not everyone got everything, not everyone found it useful, blah, 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 right? But the best way for you to learn is to try. Okay, what's happening tomorrow? Qualifiers for BlahajCTF 2025, that is true, right? It will start at 9 a.m., it will end at 9 p.m. Now, I'm not saying you sit at your computer for 12 hours straight and you don't get up to go to the restroom, you don't go and eat food, you don't tell your mother you love her, right? Those 12 hours, you own time, own target, right? Like you can spend 3 hours whacking the challenges, then you go for lunch, then you come back, then you keep whacking, then you go for dinner, you come back and keep whacking, right? It's an online qualifier. Don't turn up here. If you come here tomorrow, no one will unlock the door for you. No one will be here. I will be very sound asleep at home when the CTF starts, and I'll get like 20 tickets, being like, oh, hey, can you help me with this challenge? And I'm not going to respond to any of them. So yeah, it's online, right? Again, eyes peeled, ears open. We'll send more details in Discord in due time. But the platform, you'll find out. I haven't seen the platform either. Okay, so yeah, make sure you're verified on Discord, right? There's like a channel to go to get verified, or whatever, right? Okay, some FAQ to answer. How many challenges would there be? There will be at least 5 challenges. I can promise you there will be at least 5 challenges. How difficult are the challenges? I can confirm with certainty that everyone in this room can solve at least one challenge.
No, it's the free time. The first rank is always free.
Okay, it's not necessarily the sanity check challenge, okay? Okay, but real talk, right? No. Okay, quiet. Hey, guys, quiet a bit. I want to be serious. Hush. Okay, to be real, right? Even though I'm saying you can solve at least one challenge, with all the content that we've taught over the last 5 days, if you guys refer to the slides, if you guys try the homework, if you guys ask questions, open tickets, and follow along, I can say with some amount of certainty that for every category, the content that is covered in the slides will let you solve at least 2 to 3 to 4 challenges. Right? We have designed them to be easy and beginner friendly, and you will see direct applications to an extent of what we have covered in the last few days in those challenges. Now, I cannot say for certain for the medium and the hard and the insane challenges, right? That is the filter. That is what tells us who should get into finals and who doesn't make it to finals, right? But even for absolute beginners, if you work hard enough, if you Google hard enough, if you open 5 LLM tabs, if you ask Gemini, DeepSeek, ChatGPT, and Claude at the same time, right? If you ask all of them at the same time and you use your own brain, right, you might be able to solve the medium or even the hard or even the insane challenges. I promise you that. Right? Okay, the scoring. The scoring will be dynamic. So a lot of people asking, right, how does dynamic scoring work? Basically, every challenge will start with some number of points, I think 500. Then as more people solve the challenge, the number of points that challenge is worth will start to go down. So let's say an easy challenge gets 50 solves. At first when you solved it, it might have been worth 450 points, but by the time the competition ends, it might have gone all the way down to 100. So as the competition is growing, your score will increase based on the number of challenges you solve, but it will decrease as the number of challenges that other people solve goes up as well. So this means harder challenges will be worth more points. Easier challenges will be worth fewer points. So hedge your bets accordingly, right? We are not going to say what the easy challenges are or the medium or the hard ones, because the feedback from last year is that some of us, we think a challenge is easy, and then everyone says, oh, that was not easy at all. And the points reflected. So, dynamic scoring. Okay. Any other questions to do with the competition or the training or anything? Anyone, anything? Yes?
What?
Yeah, so like let's say at the start of the competition, you speed run, then you solve like 5 challenges, right? And at the start, those 5 challenges were worth 500 points each. And then you leap up, you go lie down, you non, you whatever, right? You go out, you go Haji Lane, you go Bugis, you don't play the CTF, you watch Instagram reels, whatever. And then you only have those 5 challenges solved from the start of the day. Initially, that would have been worth 2,500 points. By the afternoon, as more teams have solved it, maybe each challenge will decay to 200, 100 points. Yeah. So at the start, every challenge is worth the same number of points. But as the competition goes along, the worth of each challenge will change depending on how many people can solve it. So you might have started with 2,500 points in the morning when you solve the first 5 challenges, but then by the afternoon it can be worth only 1,000 or 500 points. Okay, any other questions? Any other questions?
You trying to buy a
Yeah, so even though we have teams playing in the open category, right? you have to remember that the point decay affects everyone equally. So there is a chance that maybe like you have some super hard challenge that all the university teams manage to solve, but you guys aren't able to solve it. The points for that will still decay, but it doesn't really affect you unless you manage to solve it, right? And if a JC secondary school poly team is able to solve a challenge, the uni team better be able to solve it too. If not, they should disband and retire. Okay, any other questions? From this side of the board, anything? Yes?
Okay, I got a question. How many of y'all will I be seeing in finals? Raise your hand. Okay, I'll be seeing y'all in finals.
Okay, to answer a question that was asked, is there a cut-off? Is that a cut-off? The answer is, well, it just depends. Because, I mean, last year, I think, if you managed to solve about half the challenges and some change, you were qualified for finals. This year, like I said, I cannot disclose how many challenges there will be tomorrow. Just know that there are at least 5.
It's just proportionate. It's just proportionate to
how well everybody else does.
Yeah, so if everyone else is able to solve a lot of the easy challenges, then obviously you need to solve all the harder ones to get in, right? Just to reiterate, 160 participants will be able to qualify for finals. It's just the top 160.
Just JC secondary. That's not included.
No. Okay, the 160 is 140 allocated to JC Sec and 20 allocated to I think.
20 up. 20 for you.
I think so.
20 for open.
Wait, is that true? Can someone fact check me? Can I get 4th mark?
Fact check. 20.
20 from open. How many from?
The rest lah.
The
rest.
Which is 140, right?
Around that. But like if the secondary schoolers manage to beat them out, then the secondary schoolers get more places.
Oh, okay. I have good news. So if the secondary school and JC CAT manages to fill all the top 160 spots, and somehow you all beat the uni teams, right? Then there will be no uni students in finals. All the 20 slots will be taken up by JC and secondary schools.
Poly is open also.
Okay, do we have any other questions? Flag hoarding. Okay, for those that are unfamiliar with the concept, right? Sometimes during CTFs, some people are really nasty and they solve the challenges but they don't submit the flags. Why? It's to give people false hope. Because like they will keep all the flags to themselves, then in like the last 10 minutes of the competition, they will submit every flag. Then they'll go from like last place to first place. Then you're like, alamak, how can I do this? Unfortunately, we can't do anything about it. All we can do is just like be really mean to the team and call them. Okay, we can just be really mean to them, right? But we can't stop them because the truth is they did solve the challenges, right? It's just they decided to submit the flags late. Okay, thing that some people did ask in the Discord, is there a scoreboard freeze? Again, similar concept, like for some CTFs, 1 hour before the competition ends, they freeze the scoreboard so that you don't know where your placement is against other teams. That's cringe. We're not going to do that because that's cringe. So there's no scoreboard freeze, right? Your points will always reflect your placement, and yeah, don't flag forward. Like if you're playing, just submit flags as you get them. There's no point in keeping them.
So even after that, we technically by this check leaderboard score.
Yes. Yeah, so the leaderboard that you will see 1 minute before the competition ends will be the leaderboard that is the leaderboard when the competition ends. Unless someone submits 20 flags in 1 minute.
So does that mean like
I mean, and the team submitted. Yeah, the team is submitting the flag.
Okay. Wait, guys, attention. Another important point, right? When you guys solve the challenges in a team, right, you are submitting the flags as a team. So obviously, like one dude in your team can solve it, and you have to submit the flag as a team. But this doesn't mean that just because your friend is in another team and he's your friend, that you take the flag and you give to him, and then he submits for his own team. Right? That's called flag sharing, and that's a bannable offense. Right? If we catch you guys flag sharing, and we have our methods, right, we will know when we flag share. Right? If you get caught flag sharing, you'll be insta-banned from the competition. You'll be disqualified.
What up? I don't know what I said.
So my last salient point before I dismiss y'all, and y'all can go home.
Lecture.
And yes, early dismissal today, so that you guys can go home and review the content and rest up for tomorrow's competition. Okay, wait, actually I've got several salient points. Okay, first, guys, attention. Her voice damn sharp, yeah? Okay, guys, salient point number one, right? Even though I'm ending the thing early, you guys can still engage with the group at the back, right? Miss Kai from CSA is still going to be around for a while longer. So before you all zao, like you all gotta pack up your stuff, stand up and move your legs anyways, so you can move your legs to the back of the room and talk to her first, then you can move. Okay, that's point number one. Point number two, right? Throughout this training, we have discouraged the use of AI very heavily, right? My dear training assistants should have been using your ChatGPT tabs if they've seen them open, should, right? But the use of AI is not explicitly banned in competition. There is no way for us to stop you from using ChatGPT because like what are we supposed to do? Like we're supposed to come to your house and see if you're using ChatGPT or what, right? So no, I cannot stop you from using ChatGPT. But when you are doing the training challenges and when you are reviewing the content from these last few days of training, I still maintain that you guys shouldn't use AI, right? As much as possible, I would much rather, like if you're reviewing the content tonight, if you're confused about something, right, open a ticket and talk to us instead, right? Unless you legit like don't understand, you feel like our answers are nonsense, then you can ask ChatGPT, right? But for the most part, try and avoid using AI while learning, because it will stunt your learning. If the AI just gives you the answer, then you won't know how you got there, right? But like I said, tomorrow there will be some